Welcome to this workshop on mortality differences. This is the wrong slide. Inequality and mortality. It's good to see you all. Thanks for coming. We have 6 papers. We have, I guess, about a little more than 4 hours. We're on a tight schedule. Do you want to?
I wanted to say 20 seconds.
Go ahead.
Okay. My name is Josh Goldstein. I'm chair of the Department of Demography and director of the Berkeley Population Center. We organize this along with CEDA, the Center for the Economics and Demography of Aging. And this is our third mini conference workshop, second this year. We'll be having another one this spring on community and environment, on health. That's going to be at the end of the spring. And we're looking for topics for next year. So send your suggestions to us, to Liz, to Leora, to me. Also, if you have suggestions for how the format of these meetings could be improved, we'd love to hear about it. So I'm looking forward to a great afternoon. And thank you, a special thank you to Ron for voluntarily organizing this. So thank you.
Okay, I'm going to start my time. So we have 6 presentations, 35 minutes scheduled for each. The idea is to have a presentation of 25 minutes and then have 10 minutes of discussion. That's a lot of discussion. So you all should be writing down questions and getting ready to comment. And I think it would be best if you hold questions until the end of the presentation, if you possibly can. Okay, so I'm going to be talking about a report that is still in progress of a National Academy of Sciences study committee on the growing gap in life expectancy by income and the consequences and policy responses of that gap. And I and Peter Orszag are the co-chairs of that committee, and they're these other distinguished members, including Alan Auerbach here at Berkeley and a member of CEDA. So first, to give an overview, I should say this is a committee project, and there are many details, and I don't know all the details, but I'll do my best to answer questions. So a few years ago, I was very skeptical about the idea that mortality differentials by socioeconomic status were widening in the US. When I heard these claims, I went and looked at black-white life expectancy differences, and I saw that those were shrinking. And I thought, okay, there's nothing to this, but I have to say that now I am very convinced that in fact there are widening differentials. The general topic of how these differentials affect the progressivity of different government programs is an old topic, and one of the early papers was the dissertation in demography here by Raphael Rothman, probably back in the late 1980s, something like that. There have been quite a number of other papers. Here we look more broadly at the effect on progressivity of government benefits, and we're particularly focused on the consequences of this widening. Of course, we know population aging is threatening the fiscal sustainability of government programs, and that adjustments will be necessary, are necessary. So another thing we want to look at is the way proposed policy changes, such as raising the normal retirement age, interact with this widening dispersion in mortality by socioeconomic status, and whether that's particularly burdensome for lower income people and these kinds of questions. So I'm going to show you some of the work of the committee, and I'm going to start with a bit of background on these mortality differentials and the widening in the US. So why would we care about this topic? There are many government programs and activities for which we wouldn't care. It really doesn't matter. Programs like national defense or anything that's current spending and current benefit of whatever that spending is, sort of the mortality dimension doesn't really matter. It's when there are programs that involve shifting resources over time and across age that mortality interacting with these transfer programs does matter. And Social Security, Medicare, Medicaid, survivors benefits, disability, supplemental security income. Those are the 6 programs in particular we'll be focusing on that all have some of this moving resources over time aspect about them. Now we know that ex ante, we know that people are going to die at different, some people will die young, some people will die older, and so on. There's a sort of an annuity aspect, a risk-sharing aspect to programs. We understand and don't get too upset about the fact that some people will die before they've claimed Social Security for many years, and others will claim Social Security for 40 years, and so on. That's okay, because it's a kind of, it's like insurance. It's longevity insurance of a kind. The problem arises when there are ex ante differences in expected future mortality, and that's what we have with socioeconomic differentials in mortality. There are 2 concerns about the benefit structure of these government programs. One concern is that they should be equitable, which we might think of in terms of a rate of return, an implicit rate of return that people earn by participating in these programs. That has something to do with the size of the expected future benefit stream relative to the expected the contribution stream, the present values of those. We know that pay-as-you-go transfer programs like these are not going to be actuarially fair in the sense that you get the present value of your payments is going to equal the present value of your benefits, because we're also paying for the first generations that got huge windfall gains. But we can aim for some sort of similarity or equality in rates of return for people in different groups and different individuals, and these growing disparities in mortality and survival undermine that sort of equitable treatment of different groups by the government programs. The other important consideration is that we want to provide a decent safety net for people, and that actually involves redistribution, transfers from the richer groups to the poorer groups, and so on. Okay, so that's some background. Now there's a long history of study of mortality differences by socioeconomic status in the US. An early study, famous study, is the Kitagawa and Hauser, looking at mortality differentials in 1960. As I said earlier, I thought that differences had declined since then, and as I said, black-white differences have declined quite a bit in the last 20 years, and now life expectancy at 50 differs only by 2.8 years between blacks and whites. So there's been considerable convergence there. But there's growing evidence of the opposite trend, that is widening differences by education and income, even if racial differences are narrowing. There are difficulties in measuring these links between socioeconomic status and mortality. For income, the big difficulty is that health affects ability to work and income, just as income may affect health, and so you have this reverse causality, and you get an overestimate of the effect of income on health if you just use current income, and those kinds of things come later to what a possible remedy is for that. And for education, the big problem is that the group of people who are in the low education category has shrunk. It used to be a big proportion of the population, and now it's a small proportion of the population, and so there's increasing adverse selection in that group. The people who remain with very low education today are likely to also have many other socioeconomic characteristics that generally lead to poor health and low life expectancy and so on. They're an increasingly used approach, but still not much used, is to use a position in the distribution of education rather than to use the level of education, to use something like position in the percentile distribution of educational attainment, just as is mostly done when looking at income and mortality today. I'll talk a little bit more about that in a moment. So let me just quickly go through some recent work on education and mortality. There's a paper by Mira et al., Cutler et al., 2008, that found large educational differentials within black males and within white females. So the difference between black men with less than high school and those with some college was over 8 years in life expectancy at age 25. And for white men, it was close to 8 years. And those differentials, it turns out, have been growing. They grew, over 10 years, they grew by 1 to 2 years, these differences. So here you see a convergence between black men and white men, but a divergence within those groups in socioeconomic differentials. Brian Rostron was also a demography PhD here a few years ago. He and collaborators did a study in which they paid particular attention to the measurement of education, and they report differences in life expectancy at 45 on the order of 10 to 12 years for females and 11 to 16 years for males. These are between, I think, the top education group and the bottom group. It's over a wide range, but those are enormous life expectancy differentials, and it's hard to think of those together with a black-white difference that's shrunk to 2.8 years now, but there they are in these studies. Olshansky et al. In 2012 estimated life expectancy at birth. By education, they found that for white women, life expectancy had dropped 4 or 5 years over about a 20-year period. And they find large differentials between those with less than high school and those with college or more. So those differentials are 13 years in 1990 and 14 years in 2008 for men. Huge, huge differences. Now, I don't think any of those studies really dealt with the selectivity issues. Bound and his collaborators in a recent paper introduced this educational quantile approach that I was just describing, and they found that when they did this, it was no longer the case that there was a decline in life expectancy at the lowest categories, but they did find evidence for a steepening of the gradient in any event, and they found a difference of 6 or 7 years in median age at death in 2010 between the bottom quartile, we're talking about the bottom 25% versus the top 75%. So those are very broad educational distributions. It's striking that there'd be such a big difference, 6 or 7 years, between such broad groups, I think. And there was just an NBR paper last week, which I don't have time to discuss, but it claimed there was to find no steepening. I think when I look at their results, I would interpret them as completely consistent with what I just showed. So that was the literature on education and mortality. There's Also a literature on income and mortality that started, this particular strand started with a paper by Hilary Waldron, who's at the Social Security Administration, using Social Security data for earnings histories and mortality. She used an income measure that was average non-zero earnings at ages 45 to 55, and then she was looking at life expectancy at 60 or 65. So, you know, there's not going to be direct reverse causality. There could be a background variable that's affecting both or something like that. But this goes a long way to reducing the problem of reverse causality. Well, she found, this is life expectancy at age 65. This is for the bottom half of this average mid-career earnings distribution. And this is for the top half. So this leads to the idea that most of the gains in life expectancy across these cohorts, that's about 30 years worth of birth cohorts, most of those gains have been accruing to those in the top half of the, well, maybe it's too strong to say lifetime income distribution, but mid-career income distribution. And there's been an increase of close to 5 years between the top half and bottom half over that period. Then Barry Bosworth and Burke did a paper in 2013, revised 2014, following the Waldron general design, but using health and retirement survey data with linked Social Security income data. Now mid-career earnings is average 41 to 50. And the results are quite similar to Waldron. I won't show them, but we are following Bosworth-Burke, who is following Waldron, and yeah. So what we want is the association of mid-career earnings, which are loosely related to the AIME, this sort of lifetime earnings measure that Social Security uses to set your benefits. For various reasons, we can't use that directly. But what we want is the association of this mid-career earnings variable with later mortality. And we want to control for gender and age, but we don't want to control for education or race or anything else. The progressivity is going to depend just on this simple association. Direction of causality doesn't really matter for this purpose. Okay, and then we follow the literature in using income quantiles rather than levels. Okay, I think let's skip over that. Now, the general design of sort of simulation experiments we're going to perform is that we're going to imagine a birth cohort under two different mortality regimes. The first mortality regime is the mortality regime of the birth cohort of 1930. The second is the mortality regime of a birth cohort in 1960. But in fact, in our data, we don't observe any of the mortality for the 1960 cohort in the health and retirement survey. So the 1960 cohort mortality regime we're going to be looking at is entirely an extrapolation from the fitted model that assumes that trends in mortality by income quintile continue. No, they're observed over part of this 30-year period, but as we get towards the 1960 birth cohort, the data just peter out and nothing. So you could think of this as a hypothetical high dispersion scenario that we're going to be using to assess the effects of a change of that order of magnitude. And then we also do a sensitivity test where we assume that the dispersion increases only half that much. And in general, the effects are only half as great, so you can make that adjustment. Okay, so here's what our life expectancy calculations, estimates, and projections look like. by income quintile. This is low income, high income. This is, the blue is 1930 cohort, the orange is 1960 cohort. And you can see that the gradient, sort of if you compare, say, the top to the bottom quintile, the differences are growing. And so, in fact, for males, the difference grows from 5 years to 13 years, more or less consistent with what Waldron results would point to if they were extrapolated. And for females, it's even greater. So these are large differentials that are being simulated here, but they're not really out of line with other studies like Rostrom or Olshansky or whatever. Okay. So what are the effects on benefits and taxes? So we use a micro-simulation model called the Future Elderly Model, or FEM, which was developed by Dana Goldman over the last 10 years or so and his associates. And it was really developed to simulate health and disability and mortality and program costs. And it turns out it can be, I won't say easily, but it was possible to adapt it to our needs. So that program is used to calculate the effective mortality level on present values of projected taxes and benefits received above the age of 50. Okay. Okay. So let's look at Social Security, the present value of Social Security benefits. We discount at 2.9%, and of course, survival enters in here and is the point of the whole exercise. So if we compare, you can see here that for the under 1930 cohort mortality, a low-income quintile person would have a present value of $126,000 of benefits after age 50, and a high quintile person would have $229,000, and so there's getting much more in present value, but also making more contributions. For the 1960 cohort, you can see that gradient gets steeper, and indeed the difference between the top quintile and the bottom for men in 1930 was $103,000, but 1960 mortality conditions as simulated, it would be $173,000 or $70,000 more. It's big.
What year are the dollars?
What year are the dollars? Good question. I'm guessing they're 2010.
Does this keep the distribution of earnings the same?
Well, yes. I mean, you're tracking actual individuals, and the ranking is done on mid-career earnings. The individuals may wander away, outside of that time period.
It's the pure mortality change effect that you get here. It's the pure mortality change.
That's what we're trying to do. Yes. The earnings trajectories and other things are supposed to be held the same. And this is using the program structure of 2010 that's held constant for this exercise. Okay, so a difference of $70,000, it's become, let's say, $70,000 less progressive or something of that sort due to the widening mortality differences. For females, $48,000. Now, if you look at all the benefits combined, you have this. So now this is Social Security plus Medicare plus et cetera. Again, the present value, let's say here, it was $126,000. Here for that quintile, those mortality conditions, you look at all those 6 programs, it's $400,000. And now, if you compare the interquantile differences, they've become more different by 120,000. When we look just at Social Security, it was 70. Now it's $120,000 gap induced by the widening dispersion of mortality we've simulated. And for female, it's even bigger than that. Okay, and what about the tax side? Well, we initially were not going to include taxes at all, but then we have now, because we can't go before age 50 because of the nature of HRS. But we calculate here the present value of taxes paid above age 50, personal income tax, and employers and employees payroll tax, your FICA. And so you can see there's virtually no effect or very tiny effect on that because most taxes are paid before mortality differences become important. Benefits accrue really late in life. Taxes are paid somewhat earlier. So the same is true for males and females. And if you look at the net then, for men, this difference increases by $130,000, for women by $170,000. As I've said before, the women results are less stable and less robust. But you can see this is really quite a substantial effect. It's worth worrying about and thinking about. Well, my time is just about up. Let me mention maybe a couple of these things on policy changes. This is raising the early retirement age from 62 to 64 under the 1960 cohort mortality regime. And this is the percentage point change in the present value of benefits. Well, actually, the present value of benefits goes up because in the real world, people are claiming Social Security a little bit earlier than would be optimal. So when you force them to postpone, present value of benefits goes up, and it goes up more for the higher income quintiles than for the lower quintiles because they have longer life in which to realize the higher benefits they get because of claiming later. Okay, normal retirement age. If you raise the normal retirement age to 70 under the 1960 mortality regime, the present value of Social Security benefits falls by $30,000. Not surprising it falls, we'd expect it to. Or by 25% for the bottom quintile workers, and it falls by 20% for the top quintile workers. Depending how you choose to process that, you might view that as a decline in progressivity. So there are other things, the changing the cost of living adjustment, raising the eligibility age for Medicare, which worsens progressivity, and other things we look at, but I'm out of time, so I'm going to stop now and take the questions. If there are any.
Thank you, Ron. This is totally fascinating. And we raised earlier that the issue that the estimates for women are more unstable. I was wondering if you could speak more about that, how we should think about this intersection of progressivity and gender. If there's anything else you want to comment on that.
Well, I should say first that when we assign an income and an income position to individuals, say in a household, married couple, then we're summing their incomes and dividing by the square root of 2. An obvious procedure, I'm sure, which is supposed to be a sort of adjustment for economies of scale. This is what Bosworth and Burke did. So I think what happens is that for these older cohorts, well, for the 1930 cohort, the education and earnings of women just aren't that big a determinant of the household well-being. Beyond that, we're not looking at the specific way that women's benefits are treated and calculated and the choices they have of taking their own or taking their husband's. So those are, I think, very important questions, but we're not addressing. I should also say, of course, the most important question in this whole matter is not about the effect on progressivity of benefits and so on. It's what's going on with health and mortality and what can be done to address it. But that also is not what we're talking about. Perhaps others will be. Will?
Yeah, just as a thought experiment, I'm curious how big of a change we'd have to see in progressivity of taxation on, say, the FICA or something in order to sort of undo this sort of increase in the differential.
Well, let's see. For total benefits, we were looking at a present value of $130,000. So if people are paying, say, FICA over 40 years, what is that? About $2,500 a year, but the $130,000 is discounted, and that $2,500 is undiscounted. But it gives you some idea of the order of magnitude, I guess. Is that the sort of thing you were?
Yeah, I think that's sort of helpful in understanding. I mean, not that that's sort of realistic policy prescription today on the table, but just to understand.
Yeah. So we wanted to look at some specific policies, and there were one or two, but nothing had really big effects. One thing we weren't able to evaluate was, say, basing retirement age on years of contributions or age of entering the labor force, including spells of unemployment as work years and so on, so that if you entered the labor force at, say you dropped out of high school and entered the labor force at 18 or 17 or something, then you get to retire maybe at 57 or 67 or 60 or something different than someone who went to college and graduate school and entered the labor force at 30. There are some countries that do that, but we just weren't able to get at it in the time we had and so on. Ryan, did you?
Yeah, I just wanted to say that because Toad's not here, I have to that the variances in the age of death are interesting among these subgroups as well. And although I think the differences in life expectancies have got to be driving things, that when you do something with discounting, so the present discounted value of these things, the variance may well be mattering to some extent for these different groups. Now, I'm not sure what we can say about the trends of the variance, if there even have been any. But at the beginning of the talk, you said, well, if we have annuities, we're sort of not worrying about that so much.
Yeah.
Here, a mean preserving spread is a problem when you've got a discounting thing.
Okay, but so you're thinking that there would be different variances within each of these income quintiles?
There are. Now, I don't think it's enough to wipe out the differences you're seeing here, but they sort of stack on what we're seeing.
So the bigger the variance, the let's see, what happens? The present if the variance expands, the present value
falls. I
falls
think, because you're discounting these future amounts.
Yeah. Well, it's worth thinking about. Thank you.
It's a very interesting paper.
Well, let's see, Jane.
You talked about widening mortality differentials, that's driving it, and about taxes, but not the income. And the 1930 cohort have reached their peak earning years at a time when incomes are much more compressed than they are at the time of peak earning years of the 1960 cohort. And I don't know how that intersects.
Well, I'm glad you brought this up because I think it's a very interesting and important question how, say, the widening dispersion of incomes, the widening income distribution, the earnings distribution we know is happening, how that's related to what's happening to mortality by income quintile. But by going the route of position in the distribution rather than level, we can say nothing about that. And the same is true with the education work.
I know, but I wondered if you backed it out, because the dollar value of the differences between mean the upper and the lower would be different.
It will have changed, yeah.
And it might
I
have
think
been-
I looked at those distributions once and I don't remember, which I guess means they didn't make such a strong impression on me, but I'm very interested in that question and I'm frustrated that this approach sort of just
Yeah.
steps aside from it. But exactly how to do it, once you're talking about absolute, I mean, even you're talking about absolute differences maybe, or
But what
proportionate
about-
differences within a cohort, but then how,
What about a coefficient of variation? I mean, relative to the mean of the overall, the quintiles is still very different.
Yeah.
More different than, anyway.
I'm not sure how to do it. I'm not sure how to do it with education. You get into these problems of selection, and I think there are other problems with it, with income. So I think it's an interesting project for someone to come up with a better research design. In fact, we'll have something on notch generation, social security notch generation later. Yeah, different identification strategy. Josh?
So you're looking at these programs in isolation from the overall tax and transfer system in the United States. If we were to think about these trends, the consequences for, say, in Sweden, where they're indexing things to life expectancy, we'd say, oh no, that's just terrible for the poor in Sweden, but then we think, oh, in Sweden there are other things for the poor. So how, I mean, it doesn't make sense to me really to think about this in isolation unless it's part of building up to the whole tax and transfer system in the United States, or maybe the committee has other thoughts on why you would want to look at the fairness of just
Well, for transfers to the elderly, this is kind of it, I think. You know, it's not like there's also a whole other safety net you're ignoring. Medicaid is part of that safety net. SSI is part of that safety net. And our, what should I say, our mandate was to look at population aging, blah, blah, blah.
But in that case, the income distribution of the elderly at a given age would be the thing you'd be interested in, not the fairness of how much they paid in earlier and got later, or if it's just kind of pure welfare when they're older.
Well, that wouldn't be informing policy decisions that I see. I mean, here we're looking at the effect of current policy and possible changes in policy on that distribution rather than looking at the distribution itself. Anyway, our time is up. Thank you very much.
The work I'm going to present is updated from what was in the abstract that you all have with you. I do have extra slides from that work in the abstract if anyone's interested to look at later or talk about. But this is it's identical question just with updated what I think is better quality income data. My research question is pretty straightforward. How is state-level income inequality in the United States at different points across the life course associated with mortality? Primarily, the studies have been looking at current levels of state inequality, and I'm using the HRS data where we have data on where people reported their state of birth and where they lived early in life to look at levels of income distribution at that time in those states and look at how that's related to later life mortality. So as background, I'm generally interested in how context of states is related to health. Whether looked at multiple different types of level, we can see that a large amount of heterogeneity at an ecological level in health is explained by a lot of social and economic characteristics of regions. And so this work is generally in lines of getting into that and finding out why that is. In epidemiology, I'm an epidemiologist. There's been a lot of work on income inequality, primarily using the Gini, particularly at the state level. It's been reviewed recently by Kawachi in a new chapter in the social epidemiology textbook and by Kondo in a review of this literature. And most of this was cross-sectional, some longitudinal, but none of this work that looked at exposures at different periods of time in people's lives. So why that's important is that it's pretty well recognized that disease processes begin in early life, can begin in early life. One of sort of the hallmarks of this was a study in the 1950s among men who were killed in the Korean War. And in doing autopsies on those, this was a JAMA paper by Enos, in doing autopsies on those men, they surprisingly found 77% of people were beginning signs of atherosclerosis. And so cardiovascular disease up to that time was generally thought to start kind of later in life, and they saw this process beginning much earlier. Of course, there's also other theories about in utero programming, Barker hypothesis, for which most evidence now suggests that those are pretty small effects. So there's a study by a nice meta-analysis by Huxley showing 100 grams differences in birth weight is associated with around 2 to 4 millimeters of mercury change in systolic blood pressure later in life. So any of these correlations observed are pretty small. There's also behavioral reasons why the environment in people's early life may matter for their mortality later in life. Smoking initiation primarily happens in adolescence. There's strong trajectories in obesity. So looking at these environments at different periods of time may be important. So I'm looking here at the level of a state as the level of aggregation. U.S. states are generally more homogeneous than sort of a cross-sectional comparison. So we're not getting these extreme differences in inequality. But there still is a lot going on, a lot of differences between the states. And there's, when we look at mortality by states or county around the U.S., as I was mentioning earlier, there's a large degree of heterogeneity. This is just one recent example from Chris Murray's 8 Americas paper. This is for white life expectancy for white men in the United States, ranging from 80, this is at county level, but ranging from 75 to 80 to 65 to 71. You can kind of, in your mind, overlap states where you could also see how there's a lot of heterogeneity in life expectancy by state, which you're interested in thinking about. So the income data I'm going to use is a relatively new data set that was put together by Mark Frank using HRS tax filing data to construct a state-level panel of annual income inequality measures. Given that this IRS income is truncated at some individuals at the lower end of the distribution, we're going to be using the top 10% income share, and then as a sensitivity analysis, the top 1% income share as our measure of income distribution in the states. So I'm going to show 3 maps to map out this data. One from, this data goes from 1916 up to the present. So I'm going to just show maps of what this percent share of the top 10% of income looked like in states in 1928, which was an early high, to the early 1970s, a low point, and then back up to more recent data. So the range here is the lightest green is around 30% share, up to around a 65% share for the darkest. So looking in 1928, again, when we look at this is certainly current mortality, but if you've ever looked at these health maps before, you can see it's a pretty standard pattern of worse health in the South, best health in the Midwest and sort of New England, and then somewhere in between in the West. When we start looking at these maps of the income distribution, it changes a lot over time and looks fairly different from those maps, which is actually sort of useful for thinking about these associations. So then in 1976, and this is a changing scale here, so just within that year what the distribution looks like, and then in 2012. So actually when you go across these, I'll just go back and forth a few times if it's not too annoying for people. You can see these patterns really change. You can kind of consider these relative rankings within each time period in terms of the colors. But it's not like these have been the same states over time that have had these larger differentials in the distribution of income. In fact, it's kind of tough to find any states that were sort of better in terms of that distribution throughout time. I mean, the closest I've gotten to that is South Carolina, which seems to be a little better. I mean, West Virginia more recently has had a more equitable distribution, but earlier on was not so much the case. So we do see this isn't something that's been static in the US over time. Another way of looking at that, I'm guessing people can't read that, but this is 1916 up to the present. This is the share of income in the top 10%, and this is ranging from around 20% to 50%. So this is the distribution of states across years over time from this data. And this is national data. This isn't just people that were in the data set that I'm going to be using, but this is sort of the national averages that you calculated by state. So much, we see the general trend of states similar to what you would see in the national trend. Much greater dispersion up to, this is 1940 right here. See this dropping and becoming more consistent over time, but then this heterogeneity between states as things have gone up lately kind of returning. This is the same data or same presentation format, but for the top 1% of income, going from 0 to 20%. A little bit tighter of the distribution, but still a similar pattern. So the main point here is that there is big changes in this over time, and there is a big distribution between states that we can look at. So the covariate and mortality data that I'm going to be linked to is from the Health and Retirement Study, which is from 1992 to 2012. Baseline survey was in 92 for residents, people born between 1931 and 1941, so 50 plus at baseline. New samples were added in 98, 04, and 010. And they've linked this with the National Death Index. They also do another method where they ask questions to spouses and find out about loss to follow-up. But there's fewer missing data with the NDI. The NDI is considered to be generally a pretty good linkage for mortality and allows more direct comparability of the study with other studies and CHS studies using the NDI. So the questions that I rely on in the data at baseline, they ask what state were you born in and what state did you live in when you were in school or around the age of 10. And then over the course of the study from 92 to 2012, they also ask what state people lived in. So I'm here going to use their baseline state of residence to find out what their essentially exposure was to the income inequality at the present time. Then I have a few individual level demographic controls that I'll be using in my model. So here's the distribution. Just one of the big caveats of this that I'll get to at the end is it's a fairly tight distribution of birth cohorts in this data. Most people are sort of 1930 to around 1960. So I'll be using a general linear model with a logit link function with HRS sampling weights. The dependent variable is going to be probability of death over the observed study time. For the predictor variable, I'm z-scoring the percent share of income in each year. So I'm interested in looking at that divergence within each year of the data rather than sort of the absolute level, although I'll do sensitivity analyses to that assumption, and we can talk about that more. And I'm going to be looking at 3 periods of time. The percent of earnings in the top 10% of population is my primary predictor variable of interest. As I said, at birth, at age 10, and at steady baseline, which is around 50 to 60 years old. Model 1 will be just the bivariate correlation. The model 2, I'll include some individual control variables that are essentially prior to being born in a way, so your age depending on when you were born, gender, race, and parental education to examine whether the associations still hold. So here's the primary analysis, and these are each from separate models. These are 3 different regression models where I'm just showing the parameters for the percent of the income share at birth on a z-score. So this, and this is a non-exponentiated coefficient. So this can be interpreted as, this is in terms of standard deviations. So around 3.5% increased probability of death with a 1 standard deviation greater share in the top 10 of the distribution in 10% of income. So increased risk for birth, similar at age 10, and a weaker association at adult. When I control for these covariates, the relationship looks very similar. So what we're seeing in these primary models is that the association of the distribution of income in the state where you were born in seems to have a stronger association with mortality than it does at the current time. And age 10 is also a little bit weaker. Just to show you what the correlation of these are, you could imagine someone's living in this state. They're going to be pretty correlated over time. They're correlated, but not as strongly as I might have thought. So the percent share of the income in the top 10% is correlated around 0.33 between birth and childhood. That's only 10 years apart, but correlated at 0.33. Between adult and birth, correlated around 0.1. It's a fairly weak correlation between that environment and the state. This is the correlation for the z-scored variables that I'm actually using. So essentially where that state was in the distribution at each particular year. That's a bit stronger, but still around 0.5 between birth and childhood, 0.38 for childhood and adulthood, and 0.31 between birth and adulthood. So the next models I'm going to run are having those three indicators or measures simultaneously fitted in the same model. So this is just a comparison, the same coefficients I showed you previously. And this is when I run them in the same model. There's some attenuation of the adult association there. And you see pretty strong, very similar relationships of around 1 to 3% increased risk in death with the standard deviation difference. And by the way, that standard deviation difference is around 5% additional individuals in that top 10% of the income share. So the association does not hold for looking specifically in different racial ethnic groups. So looking in whites only, we see similar associations, and when we look in blacks, we do not see that association, or actually see potentially the opposite association. Same for Latinos. So comparing the white coefficients, it's a very small sample size for Latinos in the HRS, but generally pretty null associations in this relationship. So I was wondering if that may be due to just differences in the variability in the states that blacks and Latinos generally live in, if there's just less variation in percent income share in those states. So this is the distribution. These are set on the same scale, 0.2 to 0.6 share of the top 10% in your birth state for whites, blacks, and Latinos. And so the distribution actually looks fairly similar, so that doesn't seem to be an explanation for these findings. Another analysis that I ran was looking at people who stayed in the same state their whole life. So now looking at the association, not because people were moving to a state with a different level of income inequality or income distribution, but people who stayed living in that same state at birth, age 10, and in their 50s and 60s. And that was around 40% of the HRS sample. So in this population, there's a correlation between birth and childhood of around 0.52, the level of inequality, and between adult and childhood of about 4.8, and adult and birth of around 0.49. So a stronger correlation as you'd expect in people that stayed in the same state, but still definitely not collinear. So these are just repeating these estimates in the full population. We see very similar associations in the population that stayed in that same state. So this doesn't seem to be because of people potentially moving to other states, although of course this population who stayed in a state is going to be very different generally. Just showing the differences in when I didn't use a z-score. And so a very important thing about that I failed to mention about these z-scores, or may have failed to mention, that these are z-scored within a particular year. And so all of those analyses I'm showing were looking at the relative inequality between states, essentially standardized within a particular year. So now if I just use the absolute value across the whole study, so these can't be compared directly, because these estimates are based on a scale of sort of the 0 to 1, so the whole, potentially a comparison of if there was 0% or 100% of people in that 10% of income. So the results are fairly consistent in that there's stronger associations in more share of individuals in that 10% being associated with higher mortality rates, and that those are significant. Final, I'm getting to the end. I feel like it's actually, I think this is about the last one I'm going to show. That I also want to look at the top 1%. So this is looking at the share in the top 10%. This is looking at the share in the top 1%. This is a bit, the associations with birth and age 10 are very similar, although now I'm seeing a much more equivalent strength of association with where you were as an adult, the state that you were living in. So a few caveats as I conclude here. This is a descriptive analysis. There's no strategy that I have here for causal identification. I'm trying to kind of get a first pass at evidence for what these exposures, how these exposures may matter at different periods of people's lives. It's not conditional on any other state characteristics. That prior analysis that I was talking about in the abstract looked at more characteristics using census data, but I was having to extrapolate between decennial censuses, and so there was more measurement error in how I was getting at things. So, but I could have some proxies and add characteristics of states to control for in the future. I think kind of most importantly is this issue of a fairly narrow range of birth cohort. It's hard to know if that may be what's driving things in terms of when people were born and when these people were dying and sort of the relative ranking of states at that particular period of time. I'm not looking at any sort of linearity, and although I'm looking at different periods of time where this exposure occurs, it's essentially what the level, the income distribution was in that state at that exact period of time, not sort of 5 years or 7 years earlier or 2 years earlier or anything like that. So I generally find that there's this association between a greater percent of income share in the top 10% of income distribution and risk of death. I think there is also appears to be this associated with the state that individuals were born in. It's an unknown. It's unknown the explanation to me of why, in particular, this is holding only for whites, and I think this does have implications for thinking about sort of future mortality risk when we map out the type of state someone was born in or spent their life in early in life for sort of future mortality, and that 2 to 3% is actually not, it's small, but it's not really a trivial association at all. I think in terms of moving forward on this, I use the health and retirement study data because I'm interested in biomarkers and behavioral pathways by which these kind of exposures can lead to mortality. But in terms of validating these results, the National Health Interview Study also has information on place of birth and has a much wider range of birth cohorts and a larger sample size. So this could potentially be replicated in that data set to see if these results hold. And thank you very much.
Yes, I wanted to ask, in your model, did you put, what did you do to put controls for time? Did you have a time trend, time fixed effects? Or you didn't control at all?
No, so I was not controlling for time. So I was essentially just z-scoring the district. So the only way I really addressed that was that I was, by z-scoring the state within each year, I was essentially making an equivalent, part where someone was, where a state was across that distribution, but no other factors. Yeah.
And in the maps you showed, there was strong spatial correlation, both in your predictors and in your outcome measures, though different patterns of spatial correlation. Wouldn't you gain from doing some analysis of the spatial autocorrelation structure?
Yeah, I think so. I mean, absolutely. Although, I'm surprised for a lot of other measures that I've looked at in the past, there's a much tighter correlation, as I mentioned. But no, I definitely agree with that prediction. Yeah,
So, what happens if you add the mean income?
Yeah, I don't know. That's interesting.
So that you can get from the distribution data, or the median income? what is the hypothesis? That these are not effects of the mean, but these are really effects of the variance?
I'm not sure I'm following you. In terms of, so if I put the mean earnings per state as a control variable in there?
Well, I'm thinking that
Yeah.
these individuals have two characteristics. They have their own characteristics,
Yeah.
and then they have the characteristics of the society in which they live.
Yeah.
So inequality is
Yeah.
a good proxy for something about the society in which they live, but the first thing that should help you live longer is that you yourself have more resources. So if you come from a richer state, you're going to live longer.
Yeah,
Are richer states more equal or less equal? I don't know.
Yeah. So along those lines, and I guess I forgot to put this slide in there. I have all these individual covariates, and so I controlled for individual level income and income squared. You'd expect that poor people would be from these states. They had no impact on the associations. The associations are identical. So it doesn't appear to be about that now. Yeah.
Could you elaborate a little more on why it works for, you find these associations for whites and not for blacks and Hispanics?
No, I don't know. There's a few sort of potentially artifactual things about the sampling of HRS. It's so everybody. So people were born in all of the states. So this is just an important general note to make. But HRS is not meant to be representative of particular states. So it's a structured sampling frame, and it could be due to sort of the nature of the states that HRS selected at baseline, and or differences in, so also, it's conditional on needing to survive to 50 or 60 to be included in the sample as well, which may be differential for blacks and whites. I mean, it's a sample of people who've already survived to 50 and 60 as well. Other than that, it's something I see a lot when looking at sort of individual socioeconomic measures and mortality, where you typically see stronger associations for whites than you do for blacks and Latinos, because there's just other exposures that matter for that population. So I think there's a few potential things. I think in terms of the artifactual stuff, the NHIS data is meant to be representative of states and has a much larger sample, so it'll be interesting to see if it's replicated in that data.
My question was related to the prior one a little bit. First, your cohort was people born in between the 30s and the 50s, right? So then it would seem like does it make a difference whether you were born in the 30s or the 1930 to 1940, 1940 to 50,
Yeah.
which were really such different times in the United States, and things were changing dramatically. Overall income and women going to work and all those, the Great Depression and all those things. Second is that as I was trying to think about the greater inequalities, also then I would expect that a state that has greater inequalities might have, some of them, if they're poorer, but of course, would have fewer resources for all of the population. And that may be one of the food or schools or or health services and all that stuff. So that I'm just trying to think about mechanistic.
Oh yeah, no, I completely agree. I mean, those are really the interesting questions to me. Both of those. First, on the cohorts, the importance of the differences in those cohorts, and that split. And there's plenty of power to look at that. And then as well as the mechanisms about what else is going on in those states. I mean, I think. Historically, there's not sort of ideal data going back to sort of 1930 to capture a lot of that stuff on a yearly basis. But at least with the decennial censuses and some interpolation, I can capture some approximations of some of that. But if anyone here has suggestions for good data sources to get at that over historical periods of time at the state level, I'd be very interested. Yeah.
David, there's identification, there's this thing that's using cultural economics to identify outcome movers. So let's say you wanted to just look at your samples for movers and see if it's really the birth inequality that matters versus the current state inequality that matters. That might be, and there's Tim Riel and a bunch of people using identification strategy.
Cool. Okay. This is for all-cause mortality. This is just for all-cause mortality.
Okay, did you look at any other?
No, I haven't looked at any cause specific. So I mean, there's obviously a whole bunch of so the cause specific, and then there's a lot of other outcomes available in HRS to look at to see, about the specificity of what this is associated with.
Well, so I was looking at the abstract refers to prevalence of chronic diseases.
Yeah.
But here you're talking about
Mortality.
mortality. What is the mortality measure over what time period and so on?
Yeah, so it's over the observed time in HRS. So it's as people were recruited moving forward, did they die? Up to the present time, essentially. Yeah. So the.
But then wouldn't some people have longer exposures than others?
Yeah. So differentially for some of those earlier cohorts, but so I've also run this as survival analysis as well and see relatively similar results. And so that does a better job of obviously accounting for that type of the censoring, essentially.
Okay. Are there other questions or comments? Well, I think we're back on schedule then. Thank you very much, David.
Thank you, Ron. So this is work that's joint with Luis Rosaro-Bixby, who's sitting towards the back there. And I'm going to be reporting it's in some ways an update on some work that we've presented to some of you before. And we're going to add more of an emphasis on what's going on in some of the Hispanic populations within the U.S. in comparison to what we've been studying for many years of Costa Rica to try to fit better a little bit with this theme of this particular meeting, which is more around the U.S. Types of questions. So first of all, we're going to be fitting into the larger literature around the Hispanic mortality paradox in the U.S. And then in thinking about mortality gradients more generally of Hispanic populations, whether they're in the U.S. or Latin America, I will also bring in some of our work that we have done on Costa Rica, which for those of you who haven't seen some of our earlier work, has a remarkably high life expectancy. And what we're going to be doing today is really presenting some descriptive work looking at SES gradients by Hispanicity in the U.S. and in Costa Rica compared to U.S. populations. And one of the underlying factors that's received a lot of attention in the literature that we're going to try to dig into a little bit more and come out with some paradoxes still is around the role of smoking. So I'll be mentioning that along the way quite a bit. And so I'd love to get feedback from you all about how we can push some of that forward. So for those of you who haven't seen this, this is just a standard Preston curve of international per capita income across countries and life expectancy on the y-axis. And you can see that Costa Rica itself is a middle-income country with per capita income maybe a fifth or so of the U.S. per capita income, but it has higher life expectancy, and that in and of itself is just a striking fact that I always come back to when I think about SES gradients in health and mortality, and that's part of our longer research agenda and trying to understand how Costa Rica has been able to do this. But what I want to start with today is really start thinking about the Hispanic paradox within the U.S. So these data are not ours. This is from a study by Lariski et al., which was just published in Demography this past month. And so this is hot off the press, latest numbers describing relative mortality. This is at age 65 and above in the U.S. The first set of the first column that you can see is for males, and then the second frame of this is for females. So that top point estimate is looking at the death rate ratio for blacks relative to U.S.-born to non-Hispanic whites in the U.S. So you can see that they have about a death rate ratio of 1.3 or so, right? Substantially higher than whites. So this is well known, of course. And the sort of remarkable piece about this is if you look at the lower two lines. The next one down is looking at U.S.-born Hispanics, and then the sort of lowest point estimate there is foreign-born Hispanics. And so we've sort of, in this paper, they sort of broke these out using data from the longitudinal mortality follow-ups from the National Health Interview Survey data. And what we see is that mortality at these ages is substantially lower. The point estimate for U.S.-born Hispanics is not quite significantly different from the whites, but it's certainly not any higher. And the point estimate looks substantially lower, and the foreign-born Hispanics is substantially lower. So there's some kind of sort of immigration-type paradox that we're not going to try to sort of get into here, understanding what the source of that is going to be. So that's for males. When we look at the sort of female patterns, they're similar in terms of certainly the sort of Hispanic paradox. The second column of results is what happens. So in the first column, these are just comparing sort of mortality controlling for age, sort of age distributions essentially, in a mortality hazard regression. The second column also adjusts for socioeconomic status at the individual level in the data, and there we see that then the U.S.-born Hispanics actually are substantially, significantly now, so lower mortality than U.S.-born non-Hispanic whites. And that's true both for sort of men and women. Again, we can't quite significantly distinguish between the U.S.-born Hispanics and foreign-born Hispanics, but they're both substantially better in point estimates than the U.S. So this is the sort of underlying sort of main descriptives that a lot of us are sort of familiar with, and we're going to look at this in a slightly different data set and then try to dig in a little bit further and understand what are some of these patterns by SES. That when we're seeing these substantially different gradients when we control for SES, what are they looking like? So what we're going to be doing is looking at the National Longitudinal Mortality study in the U.S. and a similar study that we have in Costa Rica. So we'll be looking at ages 40 to 89. In our data, it's going to be harder to distinguish the foreign-born Hispanics from the native-born, so we're going to have to punt on a little bit of that distinction here, and we'll be showing some of the health risk factor distributions from the NHANES and from our sort of CRELIS survey, which is a health and retirement survey type database. And then when we're looking at patterns by socioeconomic status, we're going to be using a relative inequality index, similar to what sort of Ron was talking about this morning. So we're going to be chunking people essentially into quartiles of SES and looking at people sort of relative to other people within their sort of population at different quartiles of that SES distribution. And so we'll be using a relative inequality index as a sort of covariate to look at some of these relationships. So in our data, we see somewhat similar patterns to what I just showed you in the published demography article that just came out, in that U.S. Hispanics have, as a whole, have lower death rates than the white population. U.S.-born Hispanics, somewhat more similar to the U.S. white population. U.S. blacks, much higher, of course. And then now we introduce the sort of Costa Rican data that some of you have sort of seen before. And for males, we see that relative to sort of U.S. whites, Costa Rican male mortality is substantially lower. And so this is the sort of big conundrum. For females, we actually don't find significantly different mortality relative to U.S. whites. But the Costa Rican numbers look somewhat similar to the U.S.-born Hispanics overall. which is sort of fascinating. And you know, there's sort of no inherent reason why I would expect a priori that they would look similar, but it certainly you know, forces us to think about what some of these underlying sort of pathways are going to be. When we break this up by cause of death, if you look at the very bottom of this, the lowest two causes of death in this graph are lung cancer and so COPD mortality. And these are the death rate ratios of U.S. Hispanics relative to U.S. whites. And you can see that the point estimates that all the way to the left there are the death rate ratios for the U.S. Hispanics. So this is where, you know, U.S. Hispanics have a very large advantage in terms of mortality. Right? And so the first thing that we would think about is, well, U.S. Hispanics must smoke a lot less. Okay, so we'll sort of look at that in a second for these particular cohorts to see how true that is. When we look at Costa Rica relative to sort of the U.S., we find something somewhat similar, actually. The sort of biggest death rate ratios of Costa Rica relative to U.S. whites is showing up in lung cancer. Less, not in COPD in these data, but it's in lung cancer. So this is consistent with sort of smoking-related mortality being quite important to the story.
Can you tell us what COPD is?
It's chronic obstructive pulmonary disease. So it's a smoking-related mortality cause. So then if we look at estimates of risk factors by Hispanicity in the U.S., here we have U.S. whites, U.S. Hispanics, and U.S. blacks for a number of different types of risk factors. The overall picture of this, if we're again just sort of visually eyeballing these, is that actually for most of these risk factors, they're not terribly different for whites, U.S. Hispanics, and U.S. blacks. Right? There are some small differences if we look at the relative differences. They're sort of big, but with the exception of uninsurance, and that's uninsurance under age 65 there, where Hispanics have by far the highest uninsurance rates. So close to 40% uninsured. The rest of these, the estimates really aren't terribly different in terms of overall prevalences. Yeah, Magali. Yes, I apologize. That's
So US Hispanic are always in the left?
well, for uninsurance, the U.S. Hispanic is sort of all the way on the right. The U.S. Hispanics, I think, are slightly below the black ones, if that helps. So I apologize that the colors didn't come through on the when we turn this into a PDF. Yeah, so overall, we can see some small differences, but again, I would characterize these as sort of quite modest overall. And in particular, when we look at smoking, what we see is that U.S. blacks have significantly higher smoking rates than whites and Hispanics. It's a non-trivial difference in terms of the percentage of the population, but it's not the case that the Hispanics are much lower than whites. Right? They're actually very similar to the U.S. whites in terms of the overall smoking prevalence.
Is currently smoking?
So Louise, this is current smoking, right? Yes, in this one, and we can look at sort of former smoking, et cetera, and you'll see slight differences, but they're not sort of massive. And then if we look at this between U.S. whites and Costa Ricans, we see some bigger differences, but the smoking line, so the third line there, essentially what we see is the smoking rates in current smoking is very similar between Costa Rica and the U.S. overall at these sort of age groups, which again is sort of striking a conundrum. If we're seeing so much lower smoking-related mortality, well, why is it that smoking rates are somewhat similar? Okay, so now what we're going to show is mortality by SES rank. And what we've done is essentially plotted the 4 different SES quartiles using a combination of sort of education and income, and then we've sort of plotted a sort of linear line through it and shown some confidence intervals around that sort of linear plot. What you can see on the left for men is that the top line is among U.S. blacks, and across the entire SES sort of ranking within U.S. blacks, mortality is higher than so U.S. whites, and this is again sort of relatively well known. What we see among Hispanics is what's particularly remarkable to me is that among sort of lower SES Hispanics, they vastly outperform a mortality than for whites overall. All right. For females, the lines are somewhat sort of parallel, and it looks like Hispanics are outperforming across the board. Now, this particular graph did not distinguish foreign-born from native-born Hispanics. So now I'm going to take out the foreign-born and look at this just among the native-born. Okay, and now native-born Hispanics look essentially very much like U.S. whites in terms of the pattern across the SES spectrum. Yeah.
SES rank is for the full population. Everybody is ranked in the same distribution.
So Luis.
The US population as a whole, yeah.
Okay.
Yeah. Yeah. So you see the some of the confidence intervals are getting much wider towards the top of the SES distribution for some of the minority populations. So that's why you're seeing that. Okay, so now I'll look at Costa Ricans, the same graph relative to U.S. whites. Okay, so Costa Ricans, as we've reported to this group before, have very flat SES patterns of mortality. Okay, particularly among men. Among women, there's a little bit more of a gradient here, and in fact, the Costa Rican women, the patterns look very similar to U.S. whites, but among Costa Rican men, it's very flat, and again, what's absolutely striking to me is how much worse mortality is among U.S. whites in the bottom of the SES distribution relative to Costa Ricans in the bottom of the SES distribution. And this to me is just absolutely striking how we could see this. Right? So it's not just sort of that the well-off are sort of somehow doing well in Costa Rica. It's actually completely the opposite. All right. So this is, I can sort of quantify this in terms of the slope of mortality as a function of the relative inequality index, and this sort of quantifies it among men in Costa Rica. That sort of bottom left number is essentially flat, and we can see that it's statistically quite different on average from the U.S. whites. It's sort of much smaller. Okay, so that's just quantifying the last set of graphs that we saw. So now what I'm going to look at is, well, what are the patterns of, say, smoking across SES, and what can they sort of explain about this? So if I estimate the mortality by cause of death as a function of this sort of relative inequality index, so I can ask the question, within which causes of death are we seeing the most sort of inequality in, so this is within the US across different groups, and here the confidence intervals are frankly a little bit wide, and it's hard to learn a whole lot when making this sort of comparison by these sort of cut up causes of death. It's sort of less obvious that there's significant differences by sort of lung cancer or COPD there. When I do the same thing comparing Costa Rica versus sort of US whites, what we can see at these very bottom two sort of lines, again for males in particular, is that lung cancer and COPD are going to be sort of much higher amongst the low-income, low SES groups within the U.S. All right, so there's sort of a big sort of gradient by SES in the U.S. in terms of lung cancer and COPD sort of mortality. If we just look at within those causes, whereas in Costa Rica there's essentially no particular gradient among sort of any of those different causes of death, except maybe heart disease, where there's an inverse gradient in Costa Rica for men. So if I just gonna jump. Then if I look at the prevalences of these sort of risk factors, again by sort of inequality, what am I seeing? Well, if we look at, this is sort of within the US, the third line is going to look at smoking prevalence among US whites, US Hispanics, and US blacks. And what we see is that among sort of US Hispanics, so that's going to be the line sort of farther to the left, so they have significantly flatter gradients in something like smoking in the US, okay? So that would be consistent with the idea that smoking could potentially be explaining some of this, that if the gradient in smoking behavior is actually much steeper among whites than it is among Hispanics, then that could sort of explain part of the reason why we're seeing much flatter overall mortality gradients among Hispanics as compared to whites. If I do this comparing sort of Costa Rica to the U.S. whites sort of overall, again, we see the same thing. The gradients in smoking among sort of Costa Ricans is very flat. Okay, so it's not the case in Costa Rica that smoking is concentrated among lower SES groups in the way it is sort of among the U.S. So there's the potential that smoking, again, could explain some of this. But I want to come back to this study that was just published. So this is the first graph that I showed you from the Leriski paper in demography. And there's been a series of papers which have argued that actually smoking can explain a good chunk of the relationship in the US of some of the patterns of mortality that we see. But if we look at the sort of third column here, as we go from the second column of numbers to the third column of numbers, these are the death rate ratios in the second column controlling age and SES, looking at, say, Hispanics relative to whites. And then in the third column, we add to that regression whether someone's their smoking status. So they control for current smoking, former smoking, etc. And they essentially find that controlling for smoking doesn't really move the point estimates around this sort of mortality paradox. So even though we're seeing that smoking has sort of a flatter gradient among Hispanics, when we actually sort of look at how important this is overall in explaining the Hispanic paradox, we're seeing it doesn't really explain very much of it at all, which to me is just another paradox that we're coming up with here. And I think it's actually, in the literature, people have overinterpreted some of these claims that smoking can explain a lot of this relationship, I think. And this particular finding suggests that there's more to learn here. So, this is I'm going to sort of end with again some sort of paradoxes and some ideas for where we're heading next on this. And again, I'd sort of love to hear your sort of ideas. So one thing that we're wanting to look at is, in a much more detailed way, how variation in smoking intensity and exposures can explain parts of these paradoxes. So what we're seeing is that in the Hispanic populations, even though they have very similar smoking prevalences overall, they don't have, they have much lower sort of mortality in smoking-related causes. So is it that when they say they smoke, they're smoking fewer cigarettes? So that's sort of, one can try to sort of measure that in various types of surveys. Is it the nature of where they're smoking? Is there a lot more sort of outdoor smoking or smoking in sort of well-ventilated places? Is the secondhand smoking patterns, are they somewhat different? These are sort of all questions that I think are really ripe to understand and unpack some of this sort of conventional wisdom that smoking is just so important in explaining a lot of these sort of cross-country differences that we see, because it may be that in sort of Latin American populations and something about U.S. Hispanics, maybe about where they're concentrated within the U.S. or something, or different ventilation patterns. I don't know. But one of the things that we do want to do is look at this in a number of other Latin American Hispanic populations. And this is something that sort of CETA is sort of taking on, and sort of Magali and Luis and sort of a number of others are going to be helping try to sort of improve some of the data that we have on sort of Latin American mortality patterns, so that we can really try to dig into some of these things going forward. But again, most relevant to this particular group today, though, is why are low SES sort of non-Hispanics so vulnerable in the U.S. or what is it about sort of low SES Hispanics that they seem to be protected in many ways relative to say black populations or the Costa Rican low SES. So that's where we're continuing on this agenda. So, thanks, guys. Yes, please.
You pretty well passed over the question of the women.
Yeah.
Look more like everybody else.
Now, here's a hypothesis. That's why the men are doing well. Okay? Yeah. They're in relationships. They're much more in relationships than the low socioeconomic classes that are American origin are. The wives are still there. They're doing all the traditional things that the wives do in our culture. If they're smoking in the same places, a man and a wife, all those arguments about where they smoke don't hold much water. What holds water is that the men are sort of taking their energy from the energy that the women have put into the social structure that they have.
Yeah, there's certainly a lot of hypotheses around sort of social support and the importance of social support, and we can look a little bit at co-residence patterns, et cetera. With the data that we have, we're not very well positioned to really test some of those hypotheses. But I completely take your point that I was focusing on, under the lamppost. We're seeing the big differentials among men, and so that's what I was focusing on. I'm trying to understand.
It was interesting for me that you measured SES the same way for both the recent immigrants and the ones that are second-generation Hispanics, as I wonder how education and income differs. Like, what are the ranges of the recent immigrants, and then what are the ranges of the second generation? Because that would play a part in like absolute versus relative income effects on health.
Yep, for sure, and so the nature of what a given level of education means for an immigrant who is educated abroad versus an immigrant who's educated here. Yeah, lots of interesting things to try to unpack there. I agree.
In terms of intensity, when we ask people about smoking history, we usually want to know their pack years. So there's some data on that.
Yeah, so we've looked at some of those data. So Luis, I don't know if you want to try to summarize. It hasn't been very compelling in terms of the differences so far in our data.
Yeah, we explore some of the information about the fast smoking intensity, and for women there are huge differences. Hispanic women and Costa Rican women smoke much less than US whites, but for men the intensity and everything it does not differ that much. Yeah.
And then the other important thing, particularly for cancer, is sort of interaction interactions with other environmental hazards like mining, coal blast, and so forth?
Yeah, and in terms of the cancer mortality, some chunk of this is going to be non-smoking related. But then there's an interesting question of how much does this smoking-related mortality depend on other sort of modifiers? Right? And you would think that the healthcare system in Costa Rica would be such that maybe that's sort of riskier to be a smoker in Costa Rica. And we're actually finding the opposite. So just among smokers themselves, mortality rates are lower in Costa Rica than in the U.S., which is just another conundrum that we still need to try to unpack. Yeah, Magali.
Yeah, so I had one of the things that struck me in the literature that in reviewing about the Hispanic paradox is how poorly the possible healthy migrant effect has been tackled in this issue. I know I understand it's really hard to control for, but I'm wondering if indeed there is a healthy migrant effect. I would assume that it would have a larger effect, positive effect, in terms of higher survival on the lower socioeconomic groups than on the higher group, because they would have to fight more adversity. They would be more selected than the higher socioeconomic group. And these selection factors, whether it's stronger social networks or stronger initial health status, whatever, will have an impact on their mortality later on. So I don't know how would you...
Yeah, yeah, this is really tough, and you can try to find information about descending communities and to get something about the differential selection by across SES. One of the interesting pieces of information I haven't actually seen published yet, but I've seen presented on is from MXFLS, that the data set that sort of follows migrants from Mexico into the U.S. and then follows those migrants and tests their health status in the first number of years after they've come here. And they actually find that there's much less of a paradox. In fact, that those migrants tend to be much sicker on all sorts of different indicators, and one of the hypotheses is that the types of databases we're using to look at foreign-born Hispanics are missing a lot of the most vulnerable Hispanic immigrants who are sort of undocumented, et cetera. So there may be something about selection processes into our data as well. Ken?
These are self-reported smoking. Are there studies that have really probed with biomarkers how much people are telling the truth and whether that differs by context and status?
That's a good question. Especially among sort of occasional smokers, that seems to be a particular issue. But I don't claim to be an expert on that literature, but that would be really important. And one of the things that I'd love to see is using some biomarkers to validate the intensity of smoking. So it's not the yes/no smoking, but more about the intensity that I'd love to see. Josh?
I was wondering if you could talk about Emmanuel's question a little bit, showing the graph where you had the three different groups with the relative inequality.
Yeah.
The one with the big bands.
Yeah.
Yeah, like this. Okay. So if we did this within group, so then we would see very different things for the Black and Hispanic. The cutoff points would be very, very different. Did you speculate about? I mean, one interpretation of relative inequality is that things are changing over time. That was what Ron gave. Well, here, lower quartile means something different for the Hispanics and the Blacks than it does for the whites.
Yeah.
So,
if these were very nonlinear, then sort of elongating essentially the left half of this by sort of moving part of the mass of the distribution to the right would vary these patterns more. To the extent that these are sort of fairly linear looking, there's probably not as much difference that you would get from moving some of this mass to the left.
And just as a way of answering your last question, the reason low quartile Hispanics do well is because they're actually
they're less selected.
Yeah.
Yeah. Okay, so that's fair enough.
that would be really interesting alternative specification to look at.
Doesn't explain the black.
Yeah, good idea.
I don't think we can consider.
Ryan has.
Yeah, so smoking, it's not like an anvil we're dropping on people at random, right? So some people have chosen the anvil. What occurred to me, I guess, was the following. So I think what we know about U.S. smokers is that they overestimate the negative effects on their life expectancy of smoking. And I wonder whether we could tease that out of Krellis, because we do have these data that I know Luis thinks are horrible about expected longevity, but I think it might be the case that Costa Rican smokers do not think they're going to die from smoking. And it's telling us a little bit something about the psychology of smoking in the United States that's probably very different than it is in Costa Rica.
Yeah, so the Schoenbaum paper essentially has done this in HRS.
Right.
We could do something very similar using expected longevity
because
and,
I guess
and smoking status in Krellis.
And again, Tolton's not here, so I have to speak on his behalf. I think you spelled the smoking and health is kind of a big mess because it's selection. It's not clear that smoking really kills you in some. I don't know. I guess that's the concern.
You're saying that people who sort of want to die or are less concerned about survival are people who smoke in the U.S. but not in Costa Rica?
I have a brother-in-law who's a firefighter, and he also smokes sometimes. I don't know what he would say in response to a questionnaire about this, but I think there are certain personalities that select into it when it's a small proportion of the population. You're in your peer group and you do it because they're doing it too, and it's cool. But your peer group's a certain type, and so when it's more broad, more people smoke, it's sort of normal, And I think it's a marker of risk-taking here. I'm not sure about Costa Rica. But so in other words, it's not just a treatment of both smoking's bad for your health, it's also endogenous, it's revealing something about the individual.
Or these days, maybe not people who smoked 40 years ago.
Good point. Yeah, one question in the back.
Is there any way to look at the impact of dietary changes over first generation immigrants versus subsequently adopt a more Western diet?
Yeah, there is sort of large, interesting literature on this, and in the kinds of comparisons that we're looking at here, it's really hard to tease that out separately from any of the selective migration and salmon bias kinds of issues. But there certainly is literature which has documented that later generation immigrants have substantially worse diets than the first generation, and how much that's contributing is, I think, very much an open question. Interesting pathway.
Well, thank you very much.
Thank you.
And
So we had two motivations for writing this paper. One was understanding that today urbanization involves this, urban economists often talk about urbanization as sort of a positive, and that there are positive externalities associated with it in terms of the agglomeration effects, getting people to be close together and share ideas, etc. But then there are also these negative externalities associated with congestion, and those are the ones that you're probably aware of in terms of traffic and the transmission of communicable diseases. So we wanted to understand how the urban mortality penalty historically was dissipated in hopes that that could inform policy in developing countries today. And the second part of our motivation was to enter into this public health debate, trying to understand the role of sewerage versus safe water in reducing mortality. So there's a lengthy literature on water and sewerage infrastructure and mortality. I should say that historical primary literature does not actually speak to this. At the time, there wasn't a clear understanding that water and sewerage were important for infant mortality. But obviously since that time, Cutler and Miller have a very famous paper in the Demography in 2005, where they looked at the introduction of chlorination and filtration to 13 U.S. cities and found that it reduced the crew death rate and infant deaths per population by 43%. In terms of sewerage, Katzenbaum and Rosenthal used data from Paris to look at the rollout of sewage connections in different places, and they found that a 1 standard deviation increase in either income or sanitation hookups increased life expectancy at age 1 by 5%. They couldn't look at infant mortality because of wet nurses and the phenomenon. But in terms of academicians that have looked at both of these together, that's a far thinner literature. There's some suggestive work by Kane and Rotella, which is not really well identified. And then there's Costa and Kahn, Dora Costa and Matt Kahn at UCLA, and they have a really nice chapter, part of which is dedicated to looking at water and sewerage, but part of it is also looking at what predicts spending on water and sanitation, and they have this really interesting result that shows that actually more racial diversity is positively associated with how much of municipal expenditures go to these types of infrastructure projects, which is kind of very much in contradistinction to what development economists usually find today with homophily being less predictive of public investment. And so I'll come back to that a little bit later, and we can kind of think about why that might be. So how does this paper enter, and how does it relate to the discussion that we've had so far today? So it investigates the role of both sewerage and water infrastructure in the production of infant health. It hopefully improves on the prior literature by exploiting plausibly exogenous variation. And it also includes the interaction to test whether water and sewerage are substitutes or complements in the data. And we feel like this is a policy-relevant intervention. Now, I don't want to oversell this. We are going to be looking at things at the municipality level, but we have over 200,000 infant deaths in our data. So current WASH interventions, WASH standing for water and sanitation and hygiene interventions, they, like the one that Michael Kramer is doing with many colleagues at UC Berkeley actually, they're really hard pressed to look at mortality as an outcome, because even though they're large and this study is actually multi-country, you really need a lot of scale to pick up mortality as an outcome. And then in a part of the paper, which I'm not sure I'll get to today, we look at whether the effectiveness of public health interventions is due to the infrastructure themselves, or is it due to people selecting into municipalities, people with preferences for less stench, et cetera, going into municipalities, sort of along the lines of Ryan's point about selecting into smoking. Following Gertler et al., we use age and cause-specific mortality to understand the plausibility of our results. And finally, similar to Werner Troskin, who's done a lot of this work on the impacts of race-specific cholera mortality from filtration in different parts of the U.S., we're going to look at heterogeneity and the effectiveness of the intervention by baseline municipality characteristics. And that's where we'll have a bit of an inequality story to tell as well. All right, so I'm going to tell you a little bit about the infant mortality decline, though for this audience, I'm sure you probably we could go through that part rather quickly. Then I'll delve into the intervention itself, the data, the empirical strategy, and the results. So this is probably well known to everyone here. The life expectancy conditional on living to age 20 for U.S. white males changed from 1870 to 1930 by only about 4 years. But the life expectancy conditional on birth, this E superscript 0, went from 44 years to 59 years over the same time period. So the point of this slide is just to say that infant mortality was the prime cause of low life expectancy in U.S. history, and that's also plays out in a different measure, but in this Massachusetts data that we'll be using as well in this particular study. And the infant mortality, there's 3 points to this slide. The first is what it's showing you. So it's infant mortality, infant deaths per 1,000 births over time. And the line that's continuous is the infant mortality rate for the U.S. The dotted line is infant mortality rate for Massachusetts. And the 3 points are as follows. The first is that the series doesn't extend back that far, but we claim to be studying the first large decline in infant mortality over this time period. The second claim, which you can't really see from these data, but the point is that actually due to the politicking and the pressure that Lemuel Shattuck put on the Massachusetts government, Massachusetts began collecting birth data from a very early point in time. And so the U.S. series actually derives mainly from the Massachusetts data for a long stretch of history. And so essentially when we're studying Massachusetts, we're studying the U.S. in some sense. And then the final point is that this is our analysis period here. And so we're picking up a huge part of the large decline that was seen in infant mortality in recent history. So some facts that you might already be familiar with is that infant mortality accounted for about a third of overall mortality in urban parts of the state, though of course infants themselves only account for just a couple % of the population. The other thing is that our study will be focused on the metropolitan area of Boston for the most part, and it's important to realize that a third of the population of the Commonwealth lived in the Boston metropolitan area, and about 55% of the wealth was generated in the Boston metropolitan area. And then the second bullet is that the major cause of deaths over this time period of infants was cholera, or diarrhea, or cholera infantum, and then I'll show you a graph about this third point about when the urban penalty started to diminish. So economic historians kind of like to see the primary data sometimes, and here's just a weekly bulletin of prevalent diseases discussing that. There's this really lovely quote. We have to note again the very general prevalence of intestinal disorders in the Commonwealth. And so they had lots of great nomenclature for intestinal diseases at this time, and it kind of goes to speak at just how prevalent it was. And this is what it looks like in our data. So I mentioned there's about 200,000 infant deaths in our data, and about half of those, once I code up cause of death, are actually due to respiratory or gastrointestinal diseases. And the second category here is respiratory, and then it works on down to cardiovascular being the smallest category, is that's mainly congenital in nature. And so this is the final motivational graph, just showing the urban penalty. The rural areas here are the dark line, and the urban areas are here in the lighter dotted line. And you can see that there's this big gap that is present in the beginning of our analysis period. Now, urban and rural are defined at the beginning of the analysis period. And then that gap starts to close right around 1890. Okay, so if we want to understand what led infant mortality to decline, or what led to the urban penalty to decline, we want to look at infants especially, since most deaths in urban areas were occurring in infants. We'd want to look at gastrointestinal or GI-related causes, and we want to look in urban areas preferentially. So here's a couple motivational, and that of course led us to the sewage and water infrastructure. And so here's a couple of quotes about what was going on in Massachusetts at this time on these topics. So the first quote says, "The discharge of sewage at various points surrounding the city on the flats and in shallow water is causing the formation of a grand cesspool in the center of which we were living." And then the second quote is that based on a series of hearings that are happening at the City Hall, it would appear that in various parts of the metropolitan district, including most of the finest streets, the stench is terrible, often causing much sickness. And why I like this quote, the second quote particularly, is because it's emphasizing that even on the finest streets, there was this problem of the stench, that really no one was immune to this difficulty. And even though they necessarily didn't have all of the knowledge related to germ theory, et cetera, there was an overall feeling that bad stench was bad for your health. And so that's really important, because we'll be exploiting the fact that it was really complaints by the city of Boston that led to the formation of these commissions. It was really because Boston was both the economic and the political powerhouse, as well as downstream of three rivers that were dumping sewage into it, that led to the formation of the sewerage and metropolitan water district. And we'll be exploiting the fact that the sewerage districts that were recommended were based mainly on geographical and physical characteristics in terms of where the lines were drawn. So there were three different areas that were to be drained off of three different islands: Deer Island, Moon Island, Nut Island. And if you fly into Logan, you'll still fly over Deer Island, and you'll see the big pods where the sewage still is deposited. And so what's important for our analysis is that, particularly for the sewerage district, the municipalities were compelled to join. There was no choice in that matter. And so here's just a graph or a map of the three islands, the Deer Island, Moon Island, Nut Island. Here is the three rivers, the Mystic, the Charles, and the Neponset, all discharging into Boston Harbor. And here are the red lines are the planned sewerage lines. Now, for the Metropolitan Water District, it was driven. There was a need for an increased water supply. The density was wiping out. Was projected to wipe out the supply that was already had. There was a concern that increased population density would start to pollute the watershed areas. So the idea here was to use eminent domain to construct reservoirs and aqueducts and bring water in from the western part of the state. Now, there were clear eligibility rules for this program as well. You had to be within a 10-mile radius of the state house, and then they were compelled to join. Every municipality except for two did join immediately, and so if we drop those two, we get the exact same results. So for both of these interventions, we're actually not going to be focused upon, when the municipality signed up. They almost all signed up simultaneously, so that wouldn't have given us any variation anyway. But what we'll be using is the actual exogenous completion of the project from an engineering perspective. So when did they actually finish? And there's quite a bit of evidence that when they finished was pretty much random. If you've lived through the Big Dig, I know a lot of people here probably trained in Boston, you know that they say it's going to be done and it's never done. So that's an issue. And so, and then there's a hazard model in the paper that shows that the timing is really predicted by these geographical characteristics. So, but here is where the water will be taken from now, the south branch of the Nashville River. I mean, it's a very interesting exercise in political economy. They basically flooded a town in order to build this reservoir, and then the water is brought in to Chestnut Hill Pumping Station and pumped out to all the municipalities. There are a couple of exceptions, which I can talk about in terms of Lawrence gets a filter because it allows the Essex mill to pollute its water, and so the state puts a filter there. But for the most part, they stuck to this 10-mile radius rule. So this photo is important because it gives you a sense of just what I'm talking about. I'm not talking about smaller pipes. This is actually what's being built and what we're interested in. These are the sewerage main lines that are going in and the water main lines that are being built by the state to invest in the population health. So the dates of our interventions are mainly coming from the State Board of Health, the sewerage district commissions, etc. And again, one of the wonderful pieces of data that we need that Massachusetts collected is this birth data. The infant death data, we actually, for a while, they were actually all reported in registration reports also produced by the state. But then, unfortunately, there's this very deflating line in the beginning of one of the registration books saying, due to printing costs, we will no longer be publishing infant deaths by municipality, only by county. But thankfully, these registration reports are all preserved on Family Search, and so you can actually scan the data in and get it all entered, and it includes, not only the year, but also the month and the day that the child died, so you really can distinguish infant deaths from other deaths. And then we had all of this translated, which is the cause of death data. Okay, and then we'll also include time-varying demographic controls, such as the percent foreign, male, working age, females in manufacturing, females literate, population density, which we get from the federal and state censuses occurring every 5 years, and then linear interpolation. So this doesn't reproduce well, but this is our sample. So for the most part, we'll be focusing on this Boston metropolitan area. Lawrence gets a filter, and some of these other areas, these other municipalities that are urbanized, we'll be using as controls in some of the specifications just to increase our power, but in other specifications, we'll drop them. Our empirical framework is a difference in difference design, so we're going to be looking at the log of infant mortality on water, sewerage, and then the interaction of both, where these indexes are I for municipality, J for county, and Y for year, and the panel extends to 1880 to 1915. And so S equals 1 indicates that a municipality has received a sewerage line. In one instance, when it was in Marlborough, where it was encroaching on the aqueduct, it had a sewage system built for it. W equals 1 signifies a municipality is going to be connected to the Metropolitan Water District. In one instance, there was a filter, and then the interaction of the two. So this is a standard diff and diff table where you look for balance across the interventions. So we're looking, this is the means for our covariates for the entire sample, and here it is for municipalities that only received water, only received sewage, or received both. And so what you can see here, and then doing each comparison in turn. So two things about this table. One is that it's not the, ideally, what we're exploiting is both the time variation as well as the spatial variation. And this table is only saying, ex post, people that got water and these people that got sewage, were they different? Though the hazard model sort of gets at this other question about timing. The second point is that, among all of our variables, the only thing that we're seeing leap out as different is that there's fewer % female in manufacturing in the places that got the sewerage or the both interventions, which is because the western part of our sample is really driven. The reason why the western part of Massachusetts is urbanized is because there's mills, and there's a higher % of women working in mills than are working in the industries in the eastern part of this state. But when we drop the western part of the state sample, we get similar results. So here's our main results. So here's sort of recreating Cutler-Miller, just looking at safe water. We find a negative result. We're clustering our standard errors, so it's negative but not significant. Then when we add sewerage, we have another negative sign. We add them both together. They both kind of retain similar magnitudes. When we only look at the interaction of safe water and sewerage, we get about a 22 log point reduction in infant mortality. I think that's about a 44% of the entire reduction over this time period. And then finally, when we add all these two things together, we see that it's really the interaction that seems to be driving the results. So individually, these things don't seem to be significant. Sewerage retains its negative sign, but it seems to be the interaction that's important. And this kind of comes out in a graphical version of that regression table as well. Municipalities that received both water and sewerage together pull away from those that received neither, or those individually. So the purpose of this table is more as a robustness check, just to show that if you just limited the sample to those that were in the immediate metropolitan area, you get very similar results. But again, significance is now at 10% as opposed to 5%, dropping some of the sample. And so the next, I know there are some physicians in the room, so I feel less cautious about presenting the slide as I did in economic history. But the next slide, for the faint of heart, just look at your iPad or grade some papers or something like that, because it kind of actually goes through why is this, why would we expect, why might this result that it's really the interaction of the two things that are important. And so this is the fecal oral transmission. Maybe I hope I managed expectations here, hopefully it's not too bad. But fecal, so it's the F diagram. So you have, how does feces get to food? Well, there's the finger pathway, there's flies, there's fields, and there's fluids. And so if you're just working on the safe water supply issue, you'll basically be able to just, this is a big important part, you'll be able to make sure that people are, cleaning their food with clean water and drinking clean water. And if you just work on the hygiene part, you'll be focusing on the finger part. But it's really these other channels that are sort of kind of getting back to this multiplicative risks associated with smoking, that you kind of need you need a two-hit hypothesis. You need more than one thing in order to knock out all these channels together. And this is seen also in the quote of the current Director General of the WHO, where she says, on the interactions of water, sanitation, and hygiene with health are multiple. On the most direct level, water can be the vehicle for the transmission of a large number of pathogens. Human feces is a frequent source of pathogens in the water and the environment. In fact, it is virtually impossible to have a safe water supply in the absence of good sanitation. So here is where we look for parallel trends in the pre-period, and we dummy out the difference, sort of just to check on the empirical design. And then here's where all that data entry kind of came into play. So we looked, this is just reproducing our results on infant mortality. Here's looking at the child mortality rate. So we entered in all the deaths under the age of 16 months. Now, I feel a little skittish about explaining this last column among a room of demographers, but we didn't want to enter all the deaths for each age group. We just ran out of funds. So we created a category of non-child mortality, which is essentially just the entire, all deaths subtracting off the child and infant mortality. So the idea here was, do we see effects for people over the age of 5? So I know that, had we been able to enter every single, we would have had much smaller bins for age-adjusted mortality to look at. But what we find here is there's really no effect on this non-child mortality rate, which kind of comports with what we know about mortality patterns at this time, where the adults were dying mainly of tuberculosis. And then when we look at cause of death for the infants, now we're going to be getting into some small sample size, particularly for something like cardiovascular disease, but we see the predicted results, the negative results and negative impacts are largest for gastrointestinal disease and other vaccine-preventable diseases, some of which are also fecally orally transmitted, like polio, and diphtheria can be transmitted in milk as well. So again, follow up the regression with a sort of a figure that captures all the results. Here are the results for infant mortality plotted on the left axis, child and non-child plotted on the left axis, and child and non-child on the right axis, and you see the major effects on infants and children. And if you look at GI mortality, you again see this sort of split in the sample based on treatment status, with blue being places that got both and red being places that got neither. Now, in terms of what can we do with heterogeneous treatment effects, and what can we say about disparities, right? Well, we can't say as much as we would like. If we had gone ahead and entered all the birth data, we could actually have looked at occupation of each parent, and then that would have been pretty informative. But what we did was, following Troskin, we made bins of foreign, were you in the upper 50th or lower 50th percentile of foreign-born population at the municipality level at the beginning of the period, Irish and British. And so what's interesting is that we don't see big differences in the effects. Well, we see bigger differences in the total effect of safe water and sewerage between foreign-born and less foreign versus more foreign. But when we actually decompose this to try and figure out where this is coming from, we took two of the most readily available groups, the Irish and the British, and we looked at whether places that were more heavily Irish benefited more than places that were less heavily Irish at the beginning of the period. And what we found was essentially that municipalities where there were more Irish tended to have a bigger percent reduction in response to these interventions, that places that were less Irish, and certainly this same division is not seen in the more British versus less British. And we're interpreting this as, if you think about who these migrants were, you can look at these Duncan or prestige scores in the census, and you can see that, yes, the English are doing much better than the Irish overall during this period. But it's also, just knowing the history of it, the Irish are generally migrating during this time period out of economic duress, whereas oftentimes the English and the British migrants, at least some of them, were migrating for religious persecution reasons and tended to be more professionals. So we're interpreting this as the effect being larger for the more disadvantaged. So we do some things on composition. We look at whether there is this issue that we're not using interpolated values to look at the demographic features on the left-hand side. So we're potentially limited in power to pick up compositional effects, though across the board we're not seeing major compositional effects going on here. We looked at whether just the size of the population was increasing in places that were getting these interventions, or whether the birth rate was responding. Now, one could think about why would the birth rate respond contemporaneously. There should probably be a lag structure involved here, but we're finding nothing in the contemporaneous response of birth rates, either foreign or native. And I should say that these regressions that look at birth control for population on the right-hand side. Oh, I have 0 time. Oh, okay. Well, then I can finish.
Yeah,
I can
great.
finish. That's perfect. So we investigated the combination of sewerage and water infrastructure on child and infant health. We find it's really the combination that is important, and that is consistent with other authors, but most of them look at either one or the other, and we think we have strong reasons to think that they're complementary. I said that our main takeaway is 44% of the decline over this period we attribute it to these infrastructure interventions. And I think the important caveats is that economists are often interested in individual choices and behavior. We're not looking at that. We're looking at infrastructure, and we're looking at watershed protection, not chlorination. So what's different about these things? Well, so Mike Kramer has lots of work on chlorination, as does Cutler-Miller. And chlorination, what it does is if you stick your hand into water that's been delivered by an aqueduct, you could potentially recontaminate it, right? Whereas with chlorination, you kill off those pathogens by chlorinating the water. But what's different, though, is that the Cutler-Miller paper actually comes on the heels of the types of interventions that we're talking about, these huge infrastructure projects. And so what the chlorination that they're studying is actually chlorination at the source of where you have piped water going into homes. I think it's much more difficult once you have to rely on individuals to chlorinate the water, themselves and make that an act of choice. So I have one more slide, but it's not related.
What?
Okay, so because there were a couple people, I think I've given this paper maybe 6 times, and Emmanuel Saez has been through 3 of them, and I apologize deeply for that. But what I'm interested in now is actually, these are small, but I know we talked a little bit about differences in black-white mortality and how there seems to be convergence. Well, my co-author and I, Marianne Wanamaker, have been really interested in this period around the revelation of the Tuskegee experiment. And we're not sure that this is at all driving this, but we found this very interesting pattern where you see convergence for black versus white mortality for basically every age group and every difference that you can imagine, but except for older black men. If you compare older black men either to white men or to black women, you see this really inexplicable divergence, inexplicable to us so far. So it would be really great to talk to people offline about what could be driving the divergence that we're picking up here. It appears to be due to a stagnation in life expectancy for black males during this period. But that's sort of a footnote and something that I just wanted to...
Could you say the dates again?
It's 1968 to 88, sorry. Yeah.
So there is Preston and Elo have shown that the crossover in black-white mortality at older age was due to age misclassification. So isn't that the result of
This is 55 to 85. So it'd have to be huge misclassification.
Yeah, but it was pretty substantial. I think I read that in 1940, for instance, half of the black population who say they were born in 1940 actually don't have a birth certificate, so it could be a really big effect.
Yeah, that would be almost half a century. Yeah, that would be a huge, yeah.
Okay, but let's talk about the main paper.
Sure, no, sure, absolutely. Yeah, oh, sorry.
Great paper, really cool. And reminded me of us having seen Daniel Bennett present this paper at PAA, actually. And his paper, he's got this crazy result. And I think I figured out what's going on, but it's clean water is bad, right? Clean water makes people actually be dirtier. And I think he's got infant health that actually falls, at least for the community. But I imagine what you would say is that if you do both the sewerage and the water at the same time, that sort of alleviates that issue.
Well, I think he's kind of conflating, well, not conflating is not the right word. He's looking at an infrastructure intervention and looking at the individual behavioral response to it. I'm looking at 2 really large infrastructure projects. So kind of taking choice in some sense out of it. I mean, there's obviously going to be choice in here in terms of where people move and whether people decide to hook up their line to the main line. But our analysis is at the municipality level, so it's not exploring any of that. And all of that is sort of endogenous.
Well, I think the policy implication is the bottom line, right? And I think his paper, he would say, well, if you put in clean water, it turns out you get this problematic outcome. And I think that you're also speaking to a policy implication. What should we do? And so somehow they both are talking about the same kind of thing, but with different results. So what is the difference?
So I believe he was looking at this is a Bennett paper in the Philippines, is that right?
Right.
Yeah, okay. So I think he was looking at, for example, do people wash their hands and openly defecate? Well, maybe not open defecation, but do they use their latrine and things like that in response to piped water? And so, yeah, I would consider those sort of individual behavioral responses. But you're right in that he doesn't have the infrastructure of sewerage, the picture, the photo of the man standing in that pipe. I mean, what a huge project that really encompassed. He doesn't have that element to it. And I think, I also think that Steve Luby has a paper in Lancet Global Health where he actually kind of, because there's a lot of sanitation projects going on in different parts of the developing world right now, and he openly kind of questions how, what is the real return to using a pit latrine and versus defecating in the open in some areas. If you don't actually have a system to gather the excrement and move it out in a coordinated fashion, then I think the returns to individual behavior is less clear. Yeah.
I was just wondering, how was migration an issue around that period? Especially if you have selective migration, people moving from one place to another. You might think that would probably be driving your results.
Yeah, that's a really good question. So we were not really concerned about it as a threat. I was actually just interested in it as a potential mechanism, compositional changes and where people are moving and things like that. So there was a table, I went through it way quicker than I should have, that looked for compositional changes and responses to these interventions, and we didn't find much there.
I just had a data question. So the numerator in mortality rates are your individual death records. What is the denominator? I didn't understand that.
Total
for different
births.
ages. So how do you do mortality at older ages? Are the births by municipality? Is that the idea?
The births are by municipality, and the infant deaths are aggregated to the municipality level.
And municipalities are something big. You don't go and have your birth in one place. Or...
Yeah, it's possible. I mean, it's less likely in the 12-month period.
And then your older ages, 5, and then the non-child. Is that based on censuses then your denominators, or?
So the non-child is taking total population and subtracting out the under 5 population. So that is a census-based measure.
But you're not doing record linkage of birth records to death records, is that right?
Not at this point. I mean, it would be.
Would there be any reason to do that?
Well, it would be really nice actually to do it because, so I was talking to Catherine Erickson actually at the Caltech conference because there's a woman who's moving to UC Davis who's becoming like an expert on linkages like this. And I think it would be not only for power, but also because you can actually get more demographic information out of the birth records, and then you could consider, linking these people to the census and looking at long-term effects and things like that. So it's sort of a potential project. I think it would require some funding, but it would be doable because the birth records are all there. It's just that, if you have 200,000 infant deaths, imagine how many births you have to enter. Yeah. Well.
Yeah, so I just wanted to ask you some more about what the mechanisms are that you think are operating. 'Cause you're looking at the essentially reduced form effect of infrastructure, but this is going to be mediated through some behavior change. And this was a period, if I'm not mistaken, and there was a huge increase in indoor plumbing that was going on. And so, how much could that be, a function of these types of infrastructure changes? And we were talking about pit latrines and how you move the excrement from some place to someplace safe here. And what exactly was the technology that was occurring before the sewage? Because I think that's really important to understanding the sort of generalizability to any other context. We have to have some sense of what the technology was.
Yeah, no, that's a great question. So, so for many of these municipalities had some form of piping. These are the connecting lines, but they would often end in the nearest body of water or some sort of canal. So there wasn't any coordinated effort to move the excrement very large distances away from population centers. So that's actually where this technology is intersecting.
But it was piping from indoor plumbing, and there was some kind of plumbing, and there weren't actually a lot of outhouses that were then being transitioned to some type of plumbing at the same time.
Yeah, I would, hesitate to say that there were no outhouses at this time or there wasn't any transition going on at this time. I think what we're exploiting in terms of our variation is the timing, the precise timing that these big main lines go in, and so that's really the only effect that we're able to speak to. And I think looking at sort of heterogeneity in terms of, maybe Newton had more piping at baseline than, for instance, Lexington, and that would be interesting to explore, but I could only really look at heterogeneous effects by that sort of thing, not actually estimate a causal effect, and since I wouldn't have any instrument for that. But those are great questions. Yeah.
So I'm wondering if there's another potential comparison group that would take more data. We always think, what are you going to more data? And that's comparing to those, to the more rural areas. So this historical time period, there's some areas where rural health is actually better than the urban health. And I grew up in Western Massachusetts. When I lived there, we didn't have sewage. I grew up in a rural area. We had, the septic field, and we had a well. And so that would be the more normative. I don't know about sewage during that time, but wells would have been the common source of water, which would be relatively clean naturally at that historical time period. So I'm wondering if that gives you another comparison that would allow for a greater to identify that causal effect.
Yeah, no, that's really interesting. That's a good point. We were trying to have that balance table, that we showed you to kind of have evenness across demographic characteristics at the beginning. But that's not to say that it's not interesting in and of itself to compare the rural urban areas. And there's still an interesting decline in the rural areas that merits exploration. Interestingly, the beginning of the beginning of these state boards of health, like the first 100 pages, are dedicated to answering letters about water from various municipalities. And so this was a function that the State Board of Health just did for the entire Commonwealth. So municipalities could write in with questions about, where should they get their water and things of that nature. And so at least part of what we're seeing in the rural areas could just be this advice giving that was performed by the State Board of Health. But that is pure conjecture at this point.
Well, thank you very much.
About mortality differentials by wealth in the United States, and this is joint work with Gabriel Zuckerman. It's actually part of a paper on wealth inequality that we put together, but today I want to speak specifically about mortality differential by wealth because they have big implications on whether our estimates are believable or not. So what we do in the paper with Zuckerman is that we estimate top wealth shares. That is, what share of total wealth goes to various families, like the top 1% families, using the so-called capitalization method, where we use capital income to infer wealth. And from that strategy, we find a U-shaped pattern for wealth concentration. So this is the top 0.1% wealth share in the US over a century. So we start with high levels of wealth concentration, then a very significant deconcentration of wealth, where in the 70s, the top 0.1% gets only 7 to 8% of total wealth, down, from 20 and above. And what you see in the final decades is a very large increase in wealth concentration. Okay, so we knew that for top income shares, it has this pattern. That's what we did with Thomas Piketty. For wealth, we didn't know as much because the data is not nearly as good. So with the capitalization method, that's what you get. In contrast, 10 years ago with Wojciech Kopczuk, we had done an estimation of top wealth shares, this time using the estate multiplier method, which means you use estate tax return data, and from the wealth of the decedents, you try to infer the wealth of the living. And so when you do that, that's the pattern you get in white, okay? The white triangle. So you can see that for the first part of the period, it's very similar. You start with very high wealth concentration with both methods, a very big decrease, up to the 70s, but you can see a huge divergence in the two methods in the recent period. According to the capitalization method, the US has experienced a huge increase in wealth concentration. According to the estate method, it's been pretty flat. Okay, so is the US a country today with high wealth concentration or low wealth concentration? The two methods really give you a totally different story, and that's important, within the current debate. So all of you have heard, of course, about the Piketty's book that says, that the capitalist system is going to lead to an increase in wealth concentration. Maybe that's true, based on the capitalization method. Maybe based on the estate method, you think, look, income inequality is increasing, but that is not translating into more wealth inequality. Perhaps the high-income guys consume everything, or they give it away, etc. So really, that difference, would make a huge difference in how you interpret changes in inequality in the United States. So what I want to address here is, can this discrepancy be explained by changes in the wealth mortality gradient? Okay, so I want to show you the evidence we've put together on that. So I'm going to be fast, on the method, especially the capitalization method, because it's not, the main thing I want to discuss here. But essentially what we do there is we divide capital income by the rate of return. And the way it works, we are going to do that component by component. So we start from individual tax returns, where we see, how much each individual makes in dividends, interest, rents, business income. We compute aggregate rate of return for each asset class using flow of funds data, which are the national accounts for wealth that tell you, how many corporate equity there is outstanding, fixed claim assets, etc. And combining flow of funds with the aggregate tax data, we get an aggregate rate of return. And then we simply multiply, the individual income, or we divide it by the rate of return to get the corresponding wealth, and then we can compute the wealth at the individual level and get, the top wealth shares that I have shown. Okay, so it's actually a lot of work, to put all that data together, but it's simple conceptually, and the key assumption here for that to work is that you would need rates of returns by asset class that do not vary systematically across individuals, by wealth class. Okay, if the rich are able to get a much higher return on their corporate equity than the average, this method is going to impute them too much wealth, because we see a lot of dividends, but in reality, the wealth behind that is not as big. So there is a strong assumption, and we have a number of methods to check it. But the reason why this method gives you increasing wealth concentration, it is essentially because in the data, what is very clear is that capital income concentration has increased tremendously. So capital income is directly observed in the individual income tax data. If you look at the share of total capital income by the top 0.1% families, including all the zeros. Actually, most people don't have any capital income. You see from the 60s, to the 2012, a very sharp increase. This is a series that includes the realized capital gains, and this is a series excluding realized capital gains. Realized capital gains tend to be lumpy because you don't, realize them necessarily every year. But in any case, for any measure of capital income you are going to see a huge increase in capital income. So that, and assuming a constant, uniform rate of return implies, increasing wealth concentration. Another story at this stage, that would be plausible as well is the rich capital income concentration increases because there is an increase in the differential rate of return. Perhaps the rich now are able to get very high rates of return. So it looks like they have a lot of capital income, even though their underlying wealth is not really diverging. We don't believe that's true, and we have a number of checks with situations where you observe both wealth and capital income. Particularly, foundations are interesting because they are really wealthy institutions that have to report, rate of return and outstanding wealth, and there we see, pretty stable rates of return by size of foundations. Okay, so that's what you get. You remember this U-shape. Now, the second thing we find, though, interesting, for demography is that wealth is getting older overall, but it is actually getting younger at the very top. That is, if you look at the fraction of wealth that goes to elderly households, meaning somebody, over 65 in the household, for the total population is slightly increasing. For the top 0.1%, about half of the wealth used to be old. Now it's more, like in the high 30s, so that today, the very wealthy, in some sense, are not older, than average, or the top wealth is not older than average, which suggests that there are big demographic changes at the top. So, to put it in a very simple way, perhaps in the 60s, those were relatively older people that had accumulated, a long time ago, or perhaps received inheritances. Now it looks like it's younger people. So either they received inheritances earlier, or perhaps more realistically, they've built that wealth out of, very large incomes. Okay? The second thing that we find in the data is that the rich now also have a lot more income, and in particular labor income. So this is the share of total income and labor income held by the top 0.1% wealth holders, and it's really striking to see that top wealth holders didn't have a lot of labor income early on. Now they have actually, much more. So the very rich, they look younger, and they look also like they have much more labor income. Okay? So now, what is the estate multiplier method doing? Okay, so estate tax return data report wealth for the subsample of wealthy dissidents. Okay, so today you have to have more than $5 million in wealth to be liable for the estate tax, so you are only going to capture the 0.1%. From that estate tax data, to get to the distribution of wealth for the living, for the full population, you want to reweight by the inverse probability of death. That's what makes the descendant sample, representative of the full population. In practice, we have to use population-wide mortality by year, age, gender. But that wouldn't be enough because, we've seen here in many presentations that the high SES, in particular the wealthy, are likely to have lower mortality. Okay, so if I use the population weights, I would underestimate the reweighting because they have low probability of dying, so I should weight more for the inverse probability of death. So we need a correction for the fact that the wealthy have lower mortality. So what is done in Kopchuk-Saez, and that's following a long tradition in the estate multiplier, for lack of very good data, we use a correction, that is very rough, So what we did there was to use the differential mortality of college graduate that we found, for the 1970s from another study, and we apply it uniformly across all years. So in the 70s, we find that the college graduates perhaps have a mortality rate, 1/3 lower than the full population. And we're going to assume that the wealthy have 1/3 lower mortality for all the years from 1916 to the present. You understand that if in reality the mortality by wealth gradient is changing over time, this is going to create a bias in the trend for the estate multiplier method. Okay? And so it looks like, the two theories track each other pretty well before. After, starting in the 70s, it doesn't. So indeed, one candidate for the divergence is an increase gradient, in wealth mortality. So the idea there is that the rich start having, less and less mortality relative to the average, and therefore I underweight them with the estate multiplier more and more. So I have too few rich people, in my reweighted sample, and as a result, I get too small top wealth shares. Okay. So that let me repeat that because this is important. So for the estate multiplier to give you, an unbiased estimate, you need that conditional on year, age, gender. Wealth is not correlated with mortality. We know that the assumption is going to be false for many reasons. And here we are talking, about correlation in the data. It doesn't have to be a causal effect. What matters is just the raw correlation in the data. And there are many reasons. Some of them causal, some of them, reverse causality. So think about healthier individuals, being more economically successful and living longer. Declining health reduces economic activity and hence wealth before death. The last one is also important. Perhaps individuals give away or spend down wealth before death. Indeed, one of the most important economic theory about savings behavior is the so-called life cycle model that tells you should accumulate wealth for your retirement and then spend down and hoping to hit zero by the time you die. So if everybody was able, to do that really well, people who die wouldn't have any wealth. You see, so in that case, the estate multiplier method would go totally wrong. Okay. Okay, so that's for the level. In terms of trend biases in the estate multiplier method, there is pretty compelling evidence that U.S. mortality gradient has increased, when by education, earnings, and wealth have increased. So in wealth, there is only one study that I could find, which is by Atanasio and Oins, using the SEEP data, which is one of the very few surveys that gives you information on wealth. Here, we think that it is likely that the US mortality differential by wealth has increased through two main channels. So the first one is related to what has been discussed here, more longevity gains for the high SES group. And here, on top of that, there is likely a big composition effect related to what I shown before. Namely, if the wealthy of the past were more like trust funders, perhaps they were not much more healthy than average. Now they are likely to be more self-made, and perhaps those people, have more energy, etc., are of a more healthy type, and perhaps have a significantly different mortality. So to make progress on this, we directly evaluated the mortality gradient by wealth. So the way we did that is that we used internal individual income tax data from the IRS for the period since 1979 that has information on birth and death rates. That is, in the public data, you can't see age or age of death or birth, age of or birth date. But in the internal data, you can get access to that. So we use that data for the so-called stratified sample data that is used routinely, by IRS and government agencies for projections, etc. But what I want to say is that actually now the IRS has full population data since 1996, linked, with date of birth, date of death, some demographics, very basic demographics, that could be used for a much more detailed, mortality income analysis. So a number of people here presented, analysis by state, etc. With this, you could really get extremely precise numbers at a very local level and link that to the income situation of the individuals in a very precise way. So it's possible that in the future, for demography and link, between mortality and economic situation, that could be a great source. So here, what we're going to do is that we have to estimate wealth using the capitalization method, because that's the only way we can get at the wealth estimate. Then we can compute mortality rates on a 5-year horizon by age, gender, year, and wealth group. So we obtained two results. So the first one are the cross-sectional results. So what is the mortality rate for each group, by age, for the last decade, for various groups, the top relative to the full population sample, for the top 10%, the top 5%, and the top 1%. And I also put in red the Kopchuk assumption, that is how the mortality rate for the college graduate, back from the 70s, that was used for the estate multiplier method. So what you see very clearly is that the young have a much bigger mortality advantage. Okay, and eventually, that thing shrinks. Even if you are wealthy, at some point you are going to die, and when you are very old, that premium, has to converge to zero. The second thing that is perhaps, somewhat striking is that even within the top 10%, you still gain longevity by being even wealthier. The top 5% die with less likelihood than the top 10%, and the top 1% also has slightly lower mortality. So that's for men. And for women, you don't have perhaps as steep a gradient, but you still definitely have differences there in mortality. So that's the cross-sectional result. And then what is striking in the data is the evolution over time. So here I'm going to pick this group, the 65 to 79, which is relevant because that's really, the age where you start observing, a significant death rate, and you have a lot of, you start having people, in estate tax returns in those ages. So you can see that in the early 80s, the mortality advantage of the rich was small, actually. It was actually pretty close to 100%. And Kopchuk, the college graduate from the 70s, do better than the rich of the late 70s in terms of mortality. But you can see that over time, the mortality advantage of the rich has increased. That number has come down, and even more so for the very rich, the top 1%. You see now the top 1% has a 60% probability of dying relative to full population, while it was 90% overall. So you see a very big gain in the mortality advantage of the rich, which shows you that indeed the Kopchuk-Saez method of the estate multiplier is going to create a trend bias. Now, are those numbers enough to explain the big difference, between the initial estimates? Okay, so let me show you women next. So women show kind of a different pattern, in the sense that for the first 20 years, from the late 70s, to the 90s, it's kind of pretty flat, and then suddenly they make huge gains. So, I mean, we don't have a very good way to explain this. It could be in part a composition thing, and that is who gets married, to the wealthy people, because this is measured at the family level. Okay, so you are top 1%, based on family income. So here, the measure is not as clear. It is somewhat noisy as well because the sample is not huge, but in principle, if you were to use the full population data, you could have a very precise picture, for the last three dots. Okay. All right. So, how can we say whether this differential mortality can explain the difference between the estate multiplier method versus the capitalization method? So what we can do is to test whether the reweighted dissident sample is representative for income. Okay, because you remember what we want is the estate multiplier weights, to make the sample of dissidents representative of the full population. So what we can do is we can apply the estate multiplier weights, from Kopchuk and Saez to the individual tax returns on the subsample of those who die the next year. So those are the guys who are going, to file, if they are wealthy, the estate tax returns. We can look at those guys, the year before and look at their income. We can reweight them, using the Kopchuk-Saez multiplier method and see whether this reweighted dissident sample works well or not. And so here is what we find. If you look at capital income concentration, in black, this is the full population that I showed you before. Huge increase in capital income concentration from the top 0.1% getting 10% to getting 30% at the end of the sample. If I use my dissident sample that I reweight, using the old estate multiplier method, I get this instead. I don't see nearly as much of an increase in capital income concentration in that dissident sample. So the match was pretty good early on, but after that, I fail to capture most of the capital income concentration. So you might think, maybe because in capital income there is also business income, and when you are close to dying, you lose, your ability to carry out business activities, etc. So we can look at something that is what we call, passive capital income. That is that is only dividends, interest, rents, and trust income. Doesn't have any business income. So in principle, stuff you can get without having to put any significant labor into it. And there you still find the same pattern, that the passive capital income in the full population increases in concentration a lot, not so much for the dissident sample. So the final test we do is to say, look, let's compare now the wealth shares using the capitalization method. So in black, you have what I showed you initially, the big increase in top 0.1% wealth shares. In white, what we do is that we use the reweighted dissident sample and we apply the capitalization method. Okay? And we get the white, that is pretty flat. That is, so this very strongly suggests that the reason why the estate multiplier method fails is not so much because of the failure in the capitalization method. It's because of more and more bias, in the sample. Because when I apply the capitalization method to the people who die, I don't see an increase. Actually, it looks very similar to what we get, from estates. Okay, so this graph is often hard for people to understand because they say, look, 2-to-1, your capitalization method is beaten. Okay, but you understand that this is what comes from the capitalization method, this is what comes from the estate. And the white is what comes from the capitalization method using the so-called, dissident sample, that is as the estate works. So what's missing here that we haven't yet done, but that we'd like to do, is to say we need to find weights for estates that are going, or for the dissidents, that are going to make them representative of the full population. And once we found those weights, let's apply those weights to the estate and see whether the estate, curve shifts up this way. Okay, so that's what I wanted to say. So bottom line, large change in the mortality and wealth correlation has made the estate multiplier method unreliable. The very large change, again, is not due to a pure causal effect of, more wealth giving you more longevity. I think a lot of it has to do with composition changes. The population of the wealthy has changed significantly. It has become younger, more likely to work. And as a result, I think, that could have a large impact, on the mortality gradient for composition methods. That also suggests ways, to find new weights on the dissident sample that make it representative of the full sample, for capital income. And I think that's important, for economic analysis, because estate tax returns are a very valuable source to get at wealth. Historically, a lot of the empirical analysis in the Piketty book is really based on estate tax returns, and therefore has to use an estate multiplier method. So understanding, the demography and the mortality of the wealthy relative to the full population is critical. Otherwise, you might, get numbers that are very seriously biased. So it's a big advantage to be able to have the income and the mortality data together to make those corrections. Okay, so let me stop here. Richard.
It's a quick and dirty thing. Go back one slide and hit the three conclusions. How about a step 0, where before you found the new weights, just calculate what weights would bring your estate multiplier numbers up to the capitalization things, and then ask the question, are those weights at all reasonable? Just before you go to all this trouble to find these new weights.
Yes.
Because I have a little bit of a sense that that those hypothetical weights would astound us.
No, they would, but in some sense, you need them. Because you see, with this graph shows really you know that it's not the capitalization method per se, it's really the sample, and the weighting of the sample that makes, but I agree, those numbers have to be large. That's why I don't want to interpret them as the wealthy living longer. It could be that the wealthy are more life cycle types, they spend down now faster, when they come towards the end of their life. And that's the reason why in the correlation it looks so big. But that's a good point.
A couple of things. One, to figure out what's going on just on a political level, it would be interesting if you were able to put who was president at the time, who controlled Congress at the time. I'm serious about this, because this is a huge political debate. The second thing, I think you need a co-author, and you need a co-author who is an estate management lawyer. And because I think that's what's going on. What's going on is all this legislation, which has been designed very specifically to make these curves have a gap. And in order to understand exactly what's going on, I think this is manipulated. This is this is behavioral. It's not an accident. It's not a fault of the method. It is people are gaming it. And the proxy may be how many estate lawyers specializing in this. You get some idea what's going on. And look and see what happens.
Yeah. No, look, Yes, I mean, you know, first I am a public economist, so I am one of those tax geeks who love to know, you know, how taxes affect things, etc. So we, you know, I've presented you just a small piece, you know, related to demography and mortality, but we do a lot more about, you know, quality of the data, risks of biases because of tax avoidance. What I would say though is that it's true. Before I have done that analysis, if I could see only the estate versus the capitalization, I would think the estate guys, they manage, you know, to get big discounts on their estate. So what they report is only a fraction of the true wealth they have. And they've become more aggressive in part due to political changes. At some point, you know, Congress and the president say, let's not be too aggressive into getting, you know, the true values of estates. The fact that the capitalization method gives you the same number, you know, kind of goes against that story, because typically for estates, you want to lower the value of the estate. You don't care so much about what was the capital income before. So it's possible that some tax avoidance methods are going also to lower capital income just before death. It's possible, but it might not, you know, so that's a good question. So, Rodney.
So I'm thinking Piketty makes a big deal about the role of inter vivos transfers becoming bigger in recent years, and that would have this kind of effect.
Yes.
And I'm also wondering, I don't quite know how probate works, but if both husband and wife have to die, then you could take the product of those two gradients, and that would give you a much steeper reweighting that might produce something closer to the estate, to the capitalization thing. And then third, I'm just surprised that it didn't make really any difference when you did the reweighted decedent sample instead of the Kopchuk-Saez. How can it not make a big difference? Because it looked so different when you showed us.
When I showed you what?
The Kopchuk-Saez was flat
Yeah,
and the other was strongly.
Yes, that's this graph, except that, you know, it's widened, you know, it's only 76 to 2002, but this flat line and this one is exactly what I showed you initially. It's the same thing. Okay, it's this. It's exactly this.
Yeah, but when you were contrasting the differentials under your just looking at college-educated,
Yes,
there. One. So I would have thought it would make a big difference. You got a big trend in the differential.
Yes.
In your
yes.
You know, and in the Kopchuk-Saez you got no trend. But when you do the weighting, it didn't seem to make any difference.
No, precisely because you see that everybody gets confused with this graph.
Okay.
The white one is using the decedent sample, but then applying the same weights as Kopchuk-Saez.
Yes.
Applying the same weights as Kopchuk-Saez to show why they are wrong.
Okay.
You see, because that's easy to do. Getting the right weights involves, you know, a lot more computations, assumptions, and that's why we didn't do it. Okay, so sorry, you know, it's too many charts on this one. I had a question over there at the bottom.
Oh yeah, it's sort of along the same lines. During the period you're covering, there have been vast changes, of course, in both the computation of estates and their tax treatment. And I wondered, it sounds like a very complicated thought experiment, but would it be possible to basically sample out those changes and then run the calculations forward from some hypothetical date to 1970 or whatever, and see if the estates method and the capitalization method under that rather complicated and arbitrary analysis differ so dramatically.
Yeah. Look, you know, that's related to trying to tease out, you know, the tax avoidance, tax manipulation effects, you know, on those on those graphs. So I mean, I could talk for a long time about them. In the end, I don't think they are that large. Certainly, you know, for estates, at that time, you know, the tax rates were higher. So you had more incentives in principle, you know, to avoid the tax at the top. At the same time, you know, after Reagan, certainly there was less, you know, stringent enforcement of, you know, of the progressive taxes, and in particular, you know, the estate tax. Question.
So I'm wondering if you're estimating, you've got the same time axis on both of these curves, but it seems, again, I don't understand either method completely. The capitalization method is clearly a period method, where in 2004 you're looking at capital, at returns on capital in 2004. In the estate method, you're looking at people who die in 2004.
That's right.
So you're looking at, I would call that I assume everybody dies at the same age, 80. You're looking at the distribution of wealth in the cohort aged 80 in 2004. So I wouldn't expect these two things to be equal. I would expect them to be equal. I would expect to see the hedge fund managers today in 30 or 40 years start dying.
But look, this is the magic of the estate multiplier method. It's true, the old are more likely to die than the young. That's why I'm going, in my sample of estate tax returns of people who die, I'm going to give them a much higher weight. You are 50. You have a 1 in 200 probability or 1 in 300 probability of dying, you get a weight 300. I am 85, I have a 1 in 10 chances of dying, I get a weight of 10. So in the re-weighted sample, the age structure is going in principle to correspond, you know, back to the full population. You understand? That's the key thing of
if I'm a 50-year-old hedge fund manager,
yes.
And Ron's point, my wife is going to be alive. My third wife is going to be alive.
but it doesn't matter, because if you die, an estate tax return will be fine for you, even if you give everything to your spouse.
Okay. So if that's the case, why don't you just simply, you have your weights. Your weights are the inverse of your mortality rates that you just estimated. Why don't you, and that's what I was waiting for the graph of, to show us the decedent method with the adjusted mortality rates.
Yes, well, we didn't do that. That's a good question. We didn't do that because those things, unfortunately, you know, are kind of too noisy. I mean, I wouldn't have anything that precise, you know, year by year to do it systematically, but essentially, that's the spirit of what we want to do. Next. Yes. So that I can show a graph, you know, where the corrected estates go up. So that way, it's 2 to 1 in our favor, if you want, instead of having that confusing graph.
I guess for us, what we need to see would be what is the distribution of assets by estates by age. And so what's getting upweighted? How much of the share is from the 40-year-olds? How much of the share is from the 80-year-olds? And then.
Yeah, that's a good. That's a good point.
Last question, Jane.
I'm wondering if you could flip back a couple of graphs. I mean, this is you've been challenging the method of estate tax to estimate share of the wealth to the very wealthy. But if you go back to the mortality gradients, you had mentioned, that's really interesting, because you had mentioned that you've not only got higher wealth concentration, but you've got higher income concentration as well. So Ron's presentation and others have talked about the fact that income itself has shrunk the mortality gradient. Are you thinking that there might be a way to distinguish the wealth shrinkage of the mortality gradient relative, netting out the effect of the income concentration effect on the mortality gradient? I mean, we don't know really what's driving this.
What is true though is that in the tax data, the reason why the tax data is very good is you have precise information on both the labor income and the capital income. So as a descriptive exercise, doing correlations, for recent years, you know, since '96, yes, you could do a very precise description of the role of labor income, you know, capital income, and whether, you know, it's one, the other, etc. As a descriptive thing, correlation, not causal.
Okay, thank you very much. And I think we only have a party. celebration or something in the wake of